to these growth techniques, we are unable to control the oxygen vacancies, and moreover, strong thermal handling process leads to the interatomic diffusion across the interface. So, because of these two scenarios, it strongly influence the physical properties of metal oxides. So, and another thing is the Privosky structure, like Privosky structure material. The termination of the surface is very important, because if the termination of the surface is forming a polar discontinuity with the when the sample is preparing on non-polar substrate. So, for example, if you can deposit a lanthanum nickelate on a strontium titanate, so here the termination of the substrate is TaO2, which shares the polarity of 0 with the lanthanum oxide of positive polarity. So as a result, there is a discrimination between the valence states of nickel as well as nickel as well as titanium. So as a result, nickel is adjust the valence states from actually a 3 plus state to 2 plus state. So moreover, if the same thing happen, if you can construct the polar metals on polar substrates having a polarity of the surface termination. So there the valence states of nickel is identical to the 3 plus state. There is no such a appearance of nickel 2 plus on this material. Moreover, the growth direction of the film is also play a important role on the polar discontinuity. For example, the polar discontinuity of triple one grown film on STO substrate has a huge charge transferring behavior compared to the film grown on 001 STO substrate. So like this, a lot of growth techniques are influencing the uh, properties of heterostructure, and moreover, uh, the critical thickness of samples is also play an important role on this interfacial properties. So from all these observations, we are interested to study the unusual valence states in the heterostructure, and further influencing the states on the electrical as well as magnetic and electronic structure, how it is influenced based on the valency structure. For this purpose, we have taken the lanthanum nickelate and strontium ruthenate bilayer to identify the similarities between the interface. One condition, and another condition is lanthanum nickelate and lanthanum strontium manganese superlattice is deposited on three different oriented substrates in order to check the valency states as well as the physical properties of the superlattice. So from all these points, the steady uh, the starting point of study of the heterostructure is to determine the proper interface of the material. So here the local environmental effects on uh, lanthanum nickelate and strontium ruthenate bilayers. So here we have deposited these two bilayers by the help of pulse laser deposition, using pulse laser deposition on STO substrate. So here what we have done in order to check the interface of the lanthanum nickelate and strontium ruthenate is similar or not. So we have done the bilayer deposition while altering the deposition of layer pattern. So in first sample, we did lanthanum nickelate on STO substrate, and on top of the lanthanum nickelate sample, we have deposited strontium ruthenate. At the same time, same strontium on base substrate, strontium titanate substrate. So we have deposited the strontium ruthenate material and lanthanum nickelate on top of the strontium ruthenate. So why we did this thing? So whether the check the interfacial effects between the two layers as well as the influence of the substrate on bilayers. So all these samples are having the equal thickness 15 nanometer on two samples, both case, as well as we individually deposited lanthanum nickelate of 15 nanometer and strontium ethylate on STO substrate. So here we have done the temp measurement in order to check the interface cross section of the sample in order to find out the whether the sample has an interlay diffusion or flat surface or not. So the here we find a sharp interface formed between the lanthanum nickelate as and strontium ruthenate is seen in this picture. So, and moreover, we have seen the high resolution configuration of these samples shows that a perfect alignment of crystal arrangement on STO and LNO, and LNO and SRO is uh, well grown on the STO substrate. And moreover, the X-ray pattern of these samples shows that these samples are perfectly grown without any impurity phase. So, and from this XRD pattern, we find the lattice out of plane lattice constants, and where the lattice constants of lanthanum nickelate are shown abrupt change in the both cases. So, on the other hand, the SRO lattice constants are almost similar in both bilayers, which indicates that the lanthanum nickelate film is strongly influenced either by the influence of substrate or the strain formed between the LNO layer and SRO layer. Further understanding these samples, we have done the XPS measurement for both samples. Here, the samples have a clear cut electronic valency state shown, and especially the ruthenium sample is splits into sorry, it shows a doubly degenerated peak because of the orbital spin orbital splitting, and these values are almost comparable with the theoretical value. Moreover, the full width half maxima of ruthenium 3p peak shows that there is a huge valency a contribution from 4 plus state to 0 plus state of ruthenium. So that means here valency states of ruthenium contributes not only 4 plus state, it has other states also. So further, we have done the XPS of on the sample, second sample. So here the lanthanum nickelate is the top layer for the bilayer construction. So it shows that perfect lanthanum nickelate peak as well as combined with the nickel 2p peak. And moreover, we have found the nickel 2p half peak is nearby the satellite peak of combined lanthanum as well as nickel 2p peak. So which represents this is the peak which is helpful to understand the nickel has a 2p state also. So for understanding the nickel 2 plus 2 state, so it is very difficult to identify from this resultant of mixed states of lanthanum and nickel 2p states, because the decolorization is very difficult to for this kind of picture. So we have done the fitting for the nickel 3p peak for in the range of 85 to 60 nanometer. Here there is no contribution of lanthanum peaks nearby the nickel 3p. So we have deconvoluted this 3p peak by using the peak fitting model. So we obtained the first peak is highest contribution coming from 2 two plus state, and as well as followed by the three plus states of nickel. So from these we have done the calculation in order to get the value of sharing of nickel 3 plus and 2 plus in this model. So we have determined the ratio of nickel 3 plus to nickel 2 plus. Uh, that will give the information of how much oxygen vacancies are created in this sample. So all these uh, two XPS measurements only on top of the surface of the bilayers. So what is happening at the nearby interfacial conditions or interface? So for that purpose, we have done the depth profiling measurement by using this same XPS measurement by etching the top layer of strontium ruthenate as well as another bilayer of lanthanum nickelate. So from with the varying the etching time. So here we find that the especially the energy separation between the uh, energy separation between the RU3 sorry RU3 state is almost similar from moving from surface to interior part towards the interface. So that means here there is no variation in the valency state of RU Rutene 3P peak. So that means we indicate, so here there is no influence of oxygen deficiency or any other contribution coming from the interface. However, the other sample we did the same depth profiling measurement for this second sample. So lanthanum nickel 3P to 2 plus ratio is varying from surface to interior of the sample. That means so while moving from surface to towards the interface, the ratio of the nickel 2 plus is gradually increased. That indicates the interior part has some oxygen vacancies created here. So as a result, there is a sharp gap is opened between uh, mm, uh, the hybridization between the 3P as well as 2P state of lanthanum nickelate. So which creates a to transfer the charge from lanthanum nickelate to strontium ruthenate. And moreover, we have find the valency band offset calculations by using the XPS measurement. Here, this is in order to determine the Fermi energy level of bilayers. We have done the extrapolating the straight line fitting. From these points, we find the valency band maxima. From there to we find the change in the valency band offset by using this equation. We find that the valency band offset maxima for bilayer 1, which has a top layer of SRO is 0.02 and second bilayer has band set valency band offset minus 0.38. So these values indicate that the valency states or Fermi energy level of these two transition metal at the interface is adjusted according to the oxygen 2p states. As a result, the magnetic properties, how it is influencing on the magnetic properties due to this valency state variation as well as the valency band offset. So for this purpose, we have done the measurements of temperature dependent magnetization with varying different fields. We found that the both samples are shown ferromantic behavior, but the magnetic moment of sample one shows a higher magnetic moment, and the second one is much lower than the compared to much lower than the first sample. So, however, the opening, especially the opening of these two loops, so ZFCFC shows so So there is a spin glass behavior exists in these samples, and in this magnet. Usually, these magnetic contribution comes only from the SRO layer, because the SRO layer is exhibited ferromagnetic below 150 Kelvin, and the complete lanthanum nickelate sample shows complete paramagnetic behavior throughout the temperature scale. So that means we understood that there is a chance of this magnetic enhancement due to the interfacial effect. So for in order to understand the spontaneous magnetization nearby the transition temperature, we fitted this equation using the scaling theory. So these both are well fitted, and found that these samples are belong to 3D Heisenberg type of ferromagnet, and first sample is belong to 3D Ising type of model. And moreover, the ferromagnetic, the effective ferromagnetic interaction constant value is determined by using this formula, and which is fitted with the help of the equation is given here, and these fittings we found that the effective magnetic interaction constant value of both bilayers are much more higher than the single layer SRO sample. That means that there is a magnetic contribution is coming from the interface, which trying to give a spin glass behavior in this system. And further understanding, we have done the electrical valency state study. We have done the temperature variation of electrical resistivity. All these samples are both are metallic behavior, but SRO samples shows a metal to insulating transition temperature nearby 150 160 Kelvin. So, and the single layer of LNO shows completely metallic behavior through the temperature scale. So, but the bilayers are shown some deviated the actual single layer contribution of both SRO and LNO. That means that some contribution. Sorry. Sorry, sir. Hello.
Yes, sir. So please continue. No
Hello,
issue. Yes, sir.
Ranganathan sir.
Ah, yes, sir.
Please go ahead. Please go ahead. We are not able to hear you. That's why I called.
Okay. Okay. So the temperature, the electrical resistivity of both bilayers are shown. The contribution of individual single layer of SRO as well as LNO contribution. So for the contribution, how can I determine from this resistivity curve? So by fitting these resistivity at low temperature range from 0 to 100 Kelvin by using different charge interacting phenomena. So here the equation is shown is rho is equal to rho naught T power n. So here the n represents from 1 to 2. So particularly different physical phenomena is originated by the charge entity of electron or electron phonon, or both the combination from the electron as well as phonon interaction. So the bilayer one is well fitted for n is equal to 1 means is almost like a straight line. So this contribution is explain the underlying physical phenomena of electron phonon scattering is exist in this sample, and for the sample of SRO single layer is well followed by n is equal to 1.5. So that means here uh, here the SRO sample film is completely deviated from the sorry bilayer 1 sample is completely deviated from the contribution of SRO singulation. That means these samples are shown, some interfacial effects are there in the sample. From all these aspects, we expect this, we can summarize this topic like abrupt change in the out of lattice plane of LNO is strongly influence on the electrical as well as magnetic properties is due to the presence of valence state of nickel 2 plus state, and moreover presence of nickel 2 plus 2 plus states so is actually influencing the octahedral structures. Moreover, the presence of a nickel 2 plus state is creating a charge transferring gap between the nickel and oxygen hybridization, which helps to transform the electron from nickel valence state to ruthenium 4D state. And so another heterostructure of lanthanum nickelate and lanthanum strontium manganate samples were deposited on three different oriented samples in order to check the polarity of the samples and interfacial contribution of the samples. So here we have taken the strontium titanate substrate with three different orientations on top of the superlattice of lanthanum nickel, and LSMO samples are deposited with 10 repetitions, uh, and each of the film lanthanum nickelate having 3 nanometer and LSMO sample having almost 5 nanometer thickness. So we have kept all these repetitions and the thickness of the film through the three film depositions. So the thickness of the samples and surface morphology of studied by the X-ray reflectivity. So these samples are shown a smooth surface, and as I mentioned previously, the thickness is calculated from this X-ray reflectivity. And moreover, the XRD patterns of superlattice shown that these samples are grown in along the orientation of the substrates. So further, we have extended the this uh, further extended this measurement using the XPS instrument in order to check the valence states of lanthanum nickelate and lanthanum strontium manganate. All these samples are shown perfect valence states, especially you can see the binding energy of Mn2 plus shows that combination of 3 plus and 4 plus as well as 2 plus valence states, and nickel is shown both 2 plus states. So we have again calculate the nickel 3 plus 2, nickel 2 plus states ratios to find out the oxygen vacancies created in this. Moreover, the nickel 2 plus states of this superlattice is gradually increasing with the increasing the orientation. Sorry, with changing the orientation of the substrate. So that means that there is orientation dependent charge transferring occurred between the Mn valence state and nickel 2p state. As a result, the Mn 3 plus state sharing an electron from manganese to nickel 3 plus state, then the nickel 3 plus state turns into nickel 2 plus state. So such a transformation leads to enhance the magnetic uh, response as well as decreasing the conducting behavior of the sample, because these two samples are shows individually metallic behavior, but as a combined superlatives of these samples shows totally insulating behavior from low temperature to 300 Kelvin. That means that there is a chance of charge transferring occurred between the transition metal and of Mn to nickel state. So as a result, the magnitude of electrical resistivity is changed with varying the orientation of the substrate. So moreover, in order to understand the influencing factors or the physical phenomena behind this obtaining insulating behavior, we have fitted this resistivity versus temperature curve using the variable range hopping model. Here, the variable range hopping model we have taken for one third of the value, because this value is contributes from the electrical resistivity coming from the 2D model instead of 3D model. So the valence and moreover we have determined the density states of uh, superlatives for these three different orientations with the help of fitted value, and also using this equation we found that the density of states is almost comparable, good and comparable with the individual values of thin films. So, and further we extended the magnetic measurements for these samples. It shows that ferromagnetic contribution like previous samples, and moreover it has an opening of loop in between the ZFC and FC curves. So that means these samples also shows that spin glass behavior, and moreover the MH loops recorded at 10 Kelvin 5 Kelvin, it shows that so completely ferromagnetic behavior with the varying the remnant value of magnetic movement. From all these contribution, electrical as well as the magnetic contribution, we understood that the balancing state of Mn3 plus is sharing the electrons with the nickel 3 plus at nearby the interface. As a result, the Mn valency turns to 4 plus, as well as nickel valency turns to 2 plus. So moreover, the orientation of the substrate is playing a key role to sharing the electron between these transition metals, and so that means triple one STO, oh sorry, superlattice boron and triple one orientation is much more giving charge transferring contribution than the other two samples. So, thank you. Hello.
Yes, sir.
Yes, sir. My one finished.
Yes, sir. Actually, very nice work, sir. Actually done by you. So thank you for speaking in this international conference, and we are grateful for the time and the effort you took to share your thoughts and the experiments with us. Thank you very much, sir. And
Okay.
now here we are having hello Amol sir, Nandi sir. Okay, thank you very much, sir. Now, here today we are with us Dr. Manish Kumar Shinde. Here I am going to discuss or delivered some details regarding him. He completed his PhD in physics from the Center for the Material for Electronics Technology, CMET, Pune. The title was Synthesis Plane and the Hierarchical Nanostructure of Metal using Thermal Plasma and the metal oxide and the sulfide using the microwave assisted semi-solvothermal techniques. Sir completed his PhD from the Department of Physics, University of Pune. Area of specialization, materials, nanomaterials, and the thin film synthesis, physiochemical characterization of material and the applications of material in the photoconductors, solar cell, photocatalysis, sensor, additives, manufacturing, etc. Sir having the huge research experience, basically uh, since 2004 to 2010, he worked at a Center for Material for Electronics Technology, CMET, Pune, as a project staff member. He started his career as a project staff member. After the 2010 October to 2016 November, he worked as a senior scientist assistant at same CMET. After November 2016 to December 2020, he worked as a scientist A in same Center for Material for the Electronics Technology, CMET. And after December 2020 to till date, he is working at a CMET as a scientist B. So, sir, having the very huge experience of research since more than 16, 17 years, he is working over there. Completed his research, major research, that is four research projects are completed. Two of that is more than 15 crores principal investigator, and the two are of 4.5 CR as a project staff or member, and the four projects are going on. After that, sir, having the huge publication, that is the 60 international national journals, 65 in national and international conference, and the 5 patents are also having. Along with that, special achievements are also there. Sir, having the technology transfer, one part of rupees 14.41 lakhs, award for oral and the poster presentation 7 times. Sir delivered as an invitee lecture or the do present oral presentation 20 times, and the number of MTech MCA students guided by him, that is more than 15, and number of BTech student guided are 5. So I call to Mr. Dr. Manish sir to deliver his topic.
Uh, Thank you very much, Boyer sir, for your nice introduction. Am I audible to you?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Hello, hello.
Yes, sir. Yes, sir.
Is the screen visible to you?
No, sir. No.
Is it visible?
No, sir, not yet.
Yes, sir. Now it is visible, sir. Yes. Now you have to share your PPT, sir.
సరే అలాగా
Hello, hello.
Yes, sir.
Yes, am I audible to you now?
Yes, sir. Yes, yes.
Okay. But I am not able to share the screen.
Sir, do you click on share screen?
Yeah, I clicked it. It is showing that host disabled participant screen sharing.
Okay, 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 okay. Amol Nande, sir, kindly allow him.
Hello, sir. Hello.
Hello.
Sir.
Still it is disabled.
Okay, sir. Okay, okay. Did you log out and log in?
Okay, I'll do it. I'll do it.
प्रीती डॉक्टर काय म्हणताय
Hello. Hello. Hello.
Yes, sir.
Hello. Still it is visible, sir.
Aman, sir, are you there?
Yeah, now I am able to share it. Yeah.
Okay.
Now, can you see the screen now?
Yes, sir.
Yes, sir.
Okay. Yeah. Yes. Thank you. First of all, Bhoyat sir, thank you very much for your nice introduction. I am Dr. Manish Shinde from CIMET Pune. Today I'm going to talk about the nanomaterials for sensor applications, CIMET experience. Before that, I would like to thank the organizers for inviting me and allowing me to share my work at CIMET Pune. Especially, I would like to thank Dr. Nilesh Thakre and Dr. Amol Nande. So before I start, I would like to give you a brief introduction about my host institute. My institute name is Center for Materials for Electronics Technology, that is CIMET Pune. It comes under the Ministry of Electronics and Information Technology, MIT, Government of India. We have got 3 laboratories. One is at Hyderabad, one is at Thrissur, and one is at Pune. Pune laboratory also works as the headquarter for all the 3 laboratories for coordination of the activities. Each laboratory has got a different research mandate. CIMET Pune mainly works on materials, especially nanomaterials for energy applications, renewable energy, and CIMET Hyderabad works basically on high purity, ultra high purity materials and e-waste recycling. Whereas CIMET Thrissur works on semiconductors as well as ceramics, which are used in high frequency applications. So that way each laboratory has got its different research mandate and we work according to those mandates. So at CIMET Pune, we work on various applications of nanomaterials, especially in sensors and in renewable energy. So we have got projects running on solar cells, lithium-ion batteries, sensor developments, etc. So this is the today's topic. So what is a sensor? Basically, a sensor is a technological device that detects or senses a signal, a physical condition, or a chemical compounds, and it can be useful in various walks of our life. It is defined also as any device that can convert a signal from one form to another. That is also called as a sensor. So what are the different quantities that can be sensed in a sensor? You can sense motion, position, displacement, velocity as well as acceleration, force and strain, pressure, flow, sound, moisture, light, radiation, temperature, chemical presence. So there are different ways in which we can sense these quantities or these entities, and then we can present them in the form of some signal, and they are very useful in our day-to-day life. So what are the different physical principles of sensing? You can sense any entity that you want to sense using different ways. You can sense them using charge, field, potentials. You can sense them through capacitance. You can sense them through magnetism, induction, resistance. Then there can be a piezoelectric effect, which you can sense. Seebeck effect is there. Thermal properties of material can change. Heat transfer can change. The optical properties or the light can change. So in these ways, we can sense the material or any entity. Out of this, today I'm going to discuss about the sensors which are working on the principles of change in resistance as well as the change in light or change in the optical properties. So there are different examples of sensors. A simple thermometer is always also a sensor, a thermocouple, phototransistor, photoresistor, microphones, seismometers, hydrophones, gas sensors, optical sensors. These are the different examples of sensors. So out of these, today I'm going to discuss about 3 sensors. One is a photoresistor, one is a gas sensor, and third is an optical sensor. Photosensor is very important. Why I'm going to explain in the upcoming slides. So before that, applications of sensors are there in various fields. They are useful in automobiles, machines, robotics, in industry, in medicines, aerospace, Not only that, they are also nowadays useful in home appliances and in mobiles. Our mobile has got lots of different kind of sensors, which we do not know, but they are there and they are working. And nowadays sensors are very useful. Even there are gadgets which can monitor your health while you are doing your activities. So all those are based on different kind of sensors, and that is why development of sensors is very important. And that development can be done through judicious choice of materials, which are very useful for different sensors. So in this talk, we are going to discuss about three different types of sensors: photo sensor, optical or biointerfacial sensors, and gas sensors. In some of the sensors what I'm going to show what kind of activities we have done so far. So I'll start with the first sensor, that is photo sensor. So I'm going to discuss today about functional photoconducting material based on hierarchical nanostructures of undoped and copper doped CDS. Why we need hierarchical nanostructures, why need doping, I'm going to explain while explaining about the sensor activities of this particular photosensor. So before that, let us start with the photosensor. Basically, a photosensor or a photoconductor is a device which changes its resistance or conductance in the presence of light. The simple example is our street light control. The street lights should be automatically on during the evening or night, and they should be off during the day. That is a simple function. You can do it by employing some manpower, but there are errors. There can be problems many a times. It can be problem during rainy season or other times also, and then it will depend on the operator, the time of switching on the street lights. But if there is some device which can automatically switch off the light or switch on the light depending on the intensity of the light, then it will be very useful. So this is a simple example of a photosensor. But this is the simplest example. There are many other applications of a photosensor. And these applications are divided into two types. Conventional applications, street lights, as I told you, is one of the examples. And then there are advanced applications. So conventional applications are there, as I told you, in street light control, water purification, camera shutters, photocopier, that is Xerox machine, flame detector, smoke detectors. So these are the conventional applications of photosensor. But there are advanced applications also. They can be useful in prosthetic hands, in robotics, in optical switches, in medicine. Today I'm going to discuss about the photosensor that we have developed, keeping in mind its robotic application. So why do we need a particular sensor for robotic application? And a robot which can perform those activities. Now that robot should have an eye through which it can see in the same way as the humans see. And for that, we need a material which can have a response which is similar to the human eye response. And that is why we chose a particular material that is called as cadmium sulfide or cadmium selenide. So this is a graph which shows the human eye response. So this is basically the human eye response. And then there are various materials which are commercially now used as photosensors, which have got different which have got a response like this. This is the silicon. This is amorphous silicon. This is crystalline silicon. But if you can see, the human eye response doesn't match with these materials, but still they are in use because there was no choice. But if you look at this graph, green graph, you can see that the human eye response matches with this particular graph. And this corresponds to the material called as cadmium sulfide. It has got a band gap in the range of 1.74 to 2.42 electron volt, which lies in the visible range. And its wavelength range is 400 to 700 nanometer, which again covers our entire visible light range. And that is why we chose this material. Again, this is a electromagnetic spectrum and photoconducting materials. So you can see here for the visible light region, visible spectrum, these materials, cadmium sulfide, cadmium selenide, and silicon are very important. So we chose cadmium sulfide because it is very simple. It is cost effective. Cadmium selenide can be costly. So that is why we chose cadmium sulfide as our photosensor material. As I told you earlier, cadmium sulfide has got high sensitivity response in the visible range, matching well with the human eye. So that's why it can be used in robotic eye. Eye of the robot can be prepared using this particular material. And a very simple beaker chemistry technique. It can be carried out in any lab which has got a facility of a magnetic stirrer, and beakers are available. With that facility only, this reaction can be carried out. So we carried out the synthesis. This is as per the flowchart. Cadmium sulfide and cadmium salt and sulfur source were mixed together. Cadmium salt was cadmium acetate, sulfur source was thiourea, and then synthesis was carried out under some reducing agent. But in this case, the cadmium salt was cadmium chloride and sulfur source was sodium sulfide. So because of that, we didn't need any precipitating agent, and the reaction volume was around 400 ml. Because we wanted large quantity of material to be synthesized. So we prepared around 5 grams of material per batch, and also we carried out the doping. Now, why this doping is important? So we doped the material using a copper dopant. Why do we need doping? Basically, if you know semiconductors, there is an electron hole pair generation when it is excited through maybe light. In this present case, it is light. So when the electron hole pair is generated, it should not recombine fast, so that you will not get any signal, or you will not be able to measure it. So that recombination lifetime has to be delayed. And now that recombination lifetime is delayed by doping, because the doping introduces some defect sites in between valence band and conduction band. So when the electron gets excited from valence band to conduction band, while returning back, it will be captured at that defect site, and then slowly it will return back. So in the process, the lifetime of the electron hole recombination gets enhanced. So that is why we have done doping. But we also have noticed one more peculiar feature. While you prepare nanostructures, many defects are inherently present in the sample. So if you consider bulk cadmium sulfide, it will not show very good photoconducting properties. But if you consider nanoscale cadmium sulfide, it will the defects will be generated at the nanoscale in the cadmium sulfide, and it will also show the photoconducting properties. I'll show the results in the subsequent slides. So the nanoparticles were synthesized nanostructures were characterized using different techniques like this. So XRD shows formation of cadmium sulfide having a 002 preferred orientation. Now this 002 preferred orientation is very important for improvement in the photoconductivity. UV visible spectroscopy and PL spectroscopy showed that the band gap of this material is around 2.24 electron volt, while the PL spectroscopy showed that there are different transitions that are observed in these materials. First is the band gap transition that is observed at around 550-60 nanometer. Then there are some transitions. This is band age transition, and this is a transition which is due to the presence of defects. Now these defects helps in the improvement of electron hole lifetime, and this was observed highest what we can say the defect phase was observed for 0.1% doping of Cu. After that again it got reduced. That the reasons for that are different. I'll explain them later. Whereas if you look at the morphological features, the undoped CDS nanoparticle, that is CDS 6P sample, shows the particle size in the range of 30 to 50 nanometers. And this is the color of the undoped CDS powder. Now, when we doped it with 0.1% molar percent of copper, you can see that there is a reduction in particle size, even though the experimental conditions were same. So the particle size has reduced from 30 to 50 nanometer to 10 to 30 nanometer. Now, this is a phenomena which is attributable to doping, and it is reported by many researchers. As well as because of the doping, the color is also changed. Color is slightly darker. So doping in a way helps not only in the reduction in the particle size, it also helps in the creation of more defects, as evident from those characterization results. Now we fabricated the photosensors using these nanoparticles. So there are different ways in which you can prepare your photosensor device. So there are different techniques that are reported. Solid state is one technique, vapor phase technique is there, vacuum evaporation is there, chemical bath deposition technique is also there, chemical spraying is there, and thick film screen printing technique is also there. Solid state technique, which is pellet formation, is the commercially known technique. It is the commercially used technique, but it suffers from disadvantages like it requires more material because you have to prepare a thick pellet which is thick enough so that it will not break. Then it has to be it can be brittle, so if it is broken, then it will not be of any use. And electrode formation for measurement of photoconductivity is very difficult in those kind of pellets form. But these are the commercially available photoconductor devices are in the form of pellets only. If you look at any commercially available photoconductor, it is in the form of pellet. Another disadvantage is all those materials or all these pellets are imported from China. They are not made in India. So we have to pay a lot of money for importing them. Here we have presented a very simple technique which can substitute all the import. And it is not only that, it is better than the commercially available technique. So we use screen printing technique. So in screen printing, you just use the material in the form of a paste, print it using some squeezy, and then you dry it, and then you heat it to a particular temperature so that the paste material, that is some organic content, gets evaporated. Hello?
Hello, Manish sir. We are not able to observe your slides. We
No?
have observed that we have observed the last slide related to ZNO properties, and after that, the slide was not made next, etc. So we are watching the same slide.
Oh, sorry, but I am changing the slides here. Can you see now?
Not now.
Okay.
Because
What I will do, I will stop sharing and I'll start sharing again.
And start from the initial, means from ZNO properties, because your lecture is very interesting. We wish to learn something from it.
Sure, yeah.
Sir.
So can you see the slides now? Hello?
Yes, sir. Yes, sir. We can see now.
So shall I start from this slide only?
That would be fine.
Okay. So as I told you, this is the electromagnetic spectrum and photoconducting materials. So cadmium sulfide is the best choice for this visible spectrum. It is because of these reasons. It has got a very high sensitivity response in the visible range. Now I have changed the slide. Can you see the change?
Yes, sir.
Hello?
Yes,
Now
sir. Yes,
it is,
sir.
Okay.
yes, sir.
Okay. So it has got a very high sensitivity response in the visible range, matching well with the human eye. Then it is very rugged material. It is easy and low cost for customization. So low cost material is there. Silicon, as you know, so you need silicon technology for that, silicon wafer fabrication. So that can be a very costly technique. It has got a good linearity and excellent performance to cost ratio, and it has got a very wide band gap. And as I told you, we have to use it for robotic application. So that wide band gap is very important so that it can cover the entire visible light spectrum. So it can cover the visible light spectrum right from 200 nanometer to 700 nanometer. So we synthesize cadmium sulfide nanostructures using a very simple technique. That is a co-precipitation method, which can be done using a simple beaker and magnetic stirrer if it is there. So we used cadmium chloride as the cadmium precursor, sodium sulfide as the sulfur precursor. We mixed them in 1:1 molar ratio, and the volume of the solvent was, and water was used as a solvent. So it is a very simple technique. It can be done in any laboratory. but we doped it with some dopant. Copper chloride was used as the dopant, and we expected that copper is doped inside the material. So this is the characterization that we have done for our synthesized material. XRD shows that we obtained hexagonal cadmium sulfide phase having 002 preferred orientation. Now this 002 preferred orientation is very important for any device fabrication. Then optical studies were carried out using UV visibles and PL spectroscopy. So PL spectroscopy showed that the band gap of the synthesized nanostructures is around 2.24 electron volt, and PL spectroscopy showed the formation of different kind of peaks. So first peak is due to the band-to-band transition. The second is due to band-age transition, and this third peak is due to the presence of defects. And this third peak has shown the maximum for 0.1% copper doping. And this peak basically is very important so that the electron hole pair can be the electron hole recombination can be delayed. Now that delayed recombination helps in obtaining a very good photoconductivity. So that way this presence of defects is very important. And morphological studies using scanning electron microscopy shows that this for undoped cadmium sulfide nanoparticles, the particle size is in the range of 30 to 50 nanometers. Whereas for doping, after doping of 0.1% of Cu, the particle size has reduced. It has reduced from 30 to 50 to 10 to 30 nanometer. And it is a well-known fact that doping reduces the particle size. And not only that, you can see the change in color of the powder. It is yellowish here, it has darkened here. So that also confirms that copper is doped inside the cadmium sulfide nanoparticles. And in a way, doping not only helps in the reduction of particle size, it also helps in the creation of more defects. Now we fabricated the photoconductor using the synthesized cadmium sulfide nanoparticles. So we used a simple technique called as a thick film screen printing technique. So in thick film screen printing technique, we basically prepare a paste using some organic binder along with the synthesized powder. And now we print it. The printing is simple. It is like printing a marriage card. So in the same way, the printing is done, then the screen printed structure or pattern is allowed to dry, and then it is heated so that the organic gets burned off or it gets evaporated, and we get a film on the substrate. The substrates also we have used are initially we started with glass substrate, and later on we shifted to alumina substrate because alumina substrate is rugged, whereas the glass can be a brittle substrate. But there are many other techniques that are available. Those techniques are solid state technique, vapor phase technique, vacuum evaporation, etc. Out of those, solid state is the commercially known technique. Solid state preparation technique has certain disadvantages, like you need very large quantity of material and the pellets are formed from that material, but those pellets can be brittle, and electrode formation on those pellets is tricky because when you try to prepare the electrodes, some of the powder gets removed from the pellet. Whereas in this screen printing technique, these disadvantages are not there, and you need a very small quantity. If you need, suppose X quantity of material, you can prepare 10x photoconductor samples using the same quantity of material. So you can save a lot of material and you can save a lot of money because of that. Not only that, as you may be aware, cadmium sulfide is not so environmental friendly material. But if you break the pellet, you have to throw it away, and you are adding to the environmental pollution. But here you can, since you are using a very small quantity of material, even if there is some issue, you can scrap up the material, you can again prepare the paste and again print it. So you can reuse the material. So that is another advantage. And here we screen printed two kind of materials. One is screen printing of electrodes. So we use silver electrodes. So first the silver electrodes are screen printed, and then cadmium sulfide is screen printed on that. But we used two approaches. One was screen printing only, where we screen printed cadmium sulfide also, and we screen printed silver paste also. Our ratio for commercial materials or bulk materials was 28 to 72 of organic to inorganic. So we need 28 grams of organic material and 72 grams of inorganic material, and we then screen print it. It worked well for silver, it worked well for bulk cadmium sulfide, but at nanoscale we found out that this ratio is not working. Why? Because of the surface to volume ratio of nanoparticles. So the same organic material is not able to weight the whole cadmium sulfide powder because of the very high surface area. So we use 50-50% ratio, and then again we screen printed.
Yes, sir. Hello.
Manish sir. Manish sir, are you there? Manish sir.
Right? Hello.
Sir, your PPT is not visible.
Now is it visible?
Yes, sir. Yes, 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 sir. Yes.
Okay. Have you seen these slides before?
No, no, no. Actually, just we are going
This
to
one?
Yes, sir.
Yes,
It
yes,
was completed.
So okay. So this screen printing was not working properly for us, especially for cadmium sulfide nanostructures, because again it is because of the high surface area. The conventional technique that we are using was not working. So we changed it little bit. We used screen printing and drop casting. So screen printing was used for fabrication of the electrode, silver electrode, whereas drop casting was used for fabrication of cadmium sulfide pattern. So what we had done, we prepared first the silver electrode pattern, and then we drop casted few drops of cadmium sulfide onto that pattern, and then we allowed it to dry and heated it at 585 degrees centigrade so that the organic can be burned out and only cadmium sulfide will remain on the surface of the silver pattern. So that way we used two techniques, screen printing as well as drop casting. So sometimes you have to change your strategy based on your material properties, and that's what we learned from this whole exercise. So this is how the fabrication was done. So this is basically the silver pattern, and this is a gap, inter-electrode gap, and in that gap we have to deposit cadmium sulfide nanoparticles. Now that deposition was done by using drop casting. This is the back side of the same pattern. You will see that it is not good, but if you see from the top, you can see that now this gap is filled with cadmium sulfide nanoparticles. And now our cadmium sulfide photoconductor device is ready for testing. So we carried out the optoelectrical measurements. Again, so this is basically the photoconductivity measurement setup that we have developed at CIMET. It has got optical microscope, a sample holder, optical chopper is there, optical filters are there. Then there is a light source, Then there is a chopper control unit, a lock-in amplifier, and optical bench. So this is the optical bench that we have developed. It is like a rail, so we can move the sample holder as well as the light source, and we can vary the distance and study the effect of that distance variation on the optical properties. So this is the measurement results after we carried out the study. So when we study the sample under the dark, the resistance was around 100 mega ohm for undoped cadmium sulfide nanoparticles, and it was around 40 mega ohm for 0.1% copper dope sample. Now when we shine the light on the sample, visible light on the sample, the resistance changed from mega ohm to kilo ohm. Okay, it was 16 kilo ohm for cadmium sulfide, undoped cadmium sulfide, and it was around 27 kilo ohm for doped cadmium sulfide. So you can see the change in the sensitivity of the order of 3, 10 to the power 3. So 3 order change in the sensitivity is there. Resistance change from mega ohm to kilo ohm by just shining the visible light. Then there was another important parameter of photoconductivity, that was the speed of response. For undoped CDS sample, the speed of response was rise time was around 200 millisecond and fall time was around 30 millisecond. Whereas for copper doped CDS sample, the rise time was around 50 millisecond and fall time was around 30 millisecond. Now, why this rise time and fall time is important? It is because of the human eye response also. If you know persistence of vision of human eye, or the response time of the human eye is around 0.1 second, okay, 100 millisecond. So we wanted that response to be lesser than that. Okay. The shapes which are not simple, but these are prepared from the simple shapes like rod, complex shapes. For example, a flower. Hierarchical shapes. So we obtain different kind of hierarchical shapes using a solvothermal technique. Again, we use cadmium salt, sulfur source, DI water as the solvent, and copper dopant salt. But we carry out the reaction in the solvothermal technique. So in the solvothermal, we use an autoclave, and the reactants are heated inside that autoclave. It is like a pressure cooker. So because of the pressure that is generated for the water steam, the reaction gets fast, and also because of certain reducing agent and capping agents, we can get such hierarchical structures. So for undoped sample, we got flower-like shapes like these. But when we increase the doping concentration, you can see that this flower doesn't have spikes, undoped sample. But with increasing the doping concentration, you can see the presence of spikes on those petals, and those spikes got increased with increasing doping concentration. So that way, doping also helps to improve the morphology of the sample. And then we carried out again the photoconductivity study of the prepared samples. But we carried out the study for these 2 samples. As I told you, we use screen printing and drop casting together, and these are the patterns which we generated. You can see this is the silver, okay, and these lines basically again are the silver lines. These are interdigited pattern, it is called, and the brown color portion here and here you can see it is basically the deposited cadmium sulfide nanoparticles which are doped. But we not only stopped at just preparing this pattern and studying it, we prepared the prototypes. So these are the prototypes where you can see the wire leads. We have prepared holes here, and then we carried out took out the wires from here. And not only that, for protection from environment, like dust particles should not fall on it and other things, we encapsulate it with using using glass. Can you see the slides?
Yes,
Hello?
sir. Yes, sir. Yes, sir.
Hello?
Yes, sir.
Okay, yeah. Yeah. So we encapsulated also using the glass, and here you can see that the material that is required is very small in our case as compared to the commercial samples. And again here I have given the comparison of the results of commercial sample and our fabricated samples. So you can see these are our fabricated samples and these are the commercial samples. These are in the form of pellets. So because of that they are very thick. Okay. You can see here commercial sample, the number of turns, that those turns of interdigited pattern, you can see there are around 8 turns here, but in our case the turns are more, they are around 14 turns. And also the inter-electrode spacing is in micron in our case. Here you can see they are in mm or few hundred microns, whereas in our case it is around 50 to 100 micron. See, here it is 100 micron, whereas here you can see it is 200 to 700 micron inter-electrode spacing. The length of the pattern is also very important. For bigger sample, it is around 120 mm. For our case, it is around 50 mm. Total physical size is also very small in our case. And the material requirement is small in our case. We paired this data with So when we compared our data with the commercial data, so this is the data for the commercial samples. You can see the difference in the light resistance and dark resistance is not very much. So it is not very sensitive, dark resistance and light resistance. So it is not a sensitive device as compared to our device. In our very large difference from then 5 m mega ohm to 155 kilo ohm. So it is a very difference as compared to these samples, commercial samples. The gamma value accordingly is very less for samples. The spectroscopy is same for our case as compared to their samples. The response time again, the response time for the commercial sample is 4 millisecond to 50 millisecond. For our samples, the response time is 5 millisecond to 28 millisecond. In this particular case, for hierarchical sample that I already have shown to you, the response time is 2.1 and 25. As I told you earlier, and here in this case also, this is also example of undoped CDS hierarchical sample. This is copper dope 0.1% CDS hierarchical sample.
Hello.
These two samples.
Hello.
So for these two samples, you can see that the is less than 25, and that's one robotic eye application. Now, some prototypes just prepared a very fast. So it is industries and also in other places where you want to count different if number of people which are moving fast, you can use kind of object counters. And then we are like very accidents in the night time, because accidents occur because the light in the night in the vehicle on the opposite side of the road, that light can enter the eyes of the driver and it can cause partial blindness for few seconds only. But because of that, accidents can occur. To avoid that, we have devised this automatic car light dimmer, so that using those photo sensors only, the car light can be dimmed. So that prototype also we have developed. So these are the properties of those prepared prototypes. So these two prototypes. Now, because of those two prototypes, when we show the proof of the concept and these prototypes and showed that our sample has got a response time which is lesser than our human eye response, a company came forward and then they purchased this technology from us. So this technology transfer was done. It was titled Development of Photopatternable Silver and Photoconductor Thick Film Paste for Photosensors. This technology was purchased by a company called Ant Ceramics or Ant Innovation Private Limited, Mumbai. and the cost of technology transfer was around 40.31 lakhs. So that way we could prepare our lab skill materials, we could prepare the device, and then we could transfer this technology to an industry which is now planning it to expand it further and prepare the devices in India only. So we don't need to export now this kind of materials from China. We can prepare them in India only. So this is the summary of the work that we have carried out at CIMMET. Sir, how much time do I have? Hello? Hello?
Hello.
Sir, you can continue.
Hello?
Sir.
Hello?
हॅलो सर, शिंदे सर,
Hello?
स्लाइड्स पुन्हा फ्रीज झाले.
Hello?
हॅलो शिंदे सर,
Hello?
हा तुमच्या स्लाइड्स पुन्हा फ्रीज झाल्या.
Hello?
हॅलो शिंदे सर, आम्हाला तुमचा आवाज येत आहे.
Manish sir, you are audible here.
Hello?
Manish sir, you are audible here.
Hello? Am I audible? Hello?
You are audible. You are audible here.
Hello?
Please, Amol sir, please.
Hello?
Yes, sir. Yes, sir. Manish sir, you are audible, sir.
शिंदे सर तुम्ही audible
Hello?
आहात.
Manish sir, you are audible.
Manish sir, you are audible.
Hello. Manish sir. Hello.
Hello?
Yes, sir. Manish sir.
Hello? Hello?
Yes, sir. Manish sir, you are audible, sir. Hello.
Hello?
Yes, sir. Manish sir, you can continue, sir.
Hello?
Hello. Hello.
हा हॅलो
सर
सर.
काही नेट इश्यू
जी
आहे.
सर.
Hello? Am I audible to you?
हा सर तुमचा
Hello?
आवाज येतोय सर आमचा. हॅलो सर.
I go.
Manish sir. Hello. Hello.
Which is better than the commercially known samples. So this gave us a very good boost for our research. And then we developed two prototypes. First prototype developed was for digital object counter, where we can count the objects in any industry, and it is a very high speed object counter.
Hello.
And we also developed another prototype based on automatic car light dimmer. again we used first we used this our measurement platform for this, but then we actually used in our cars of my colleague who helped in this device development, because any research you cannot do on your own everything. So
Hello,
in
sir.
our team we have got a chemist, we have got a physicist, we have got a person having electronics background
Manish
who has
sir.
developed this
Hello.
electronic.
Manish sir, please.
Yeah, yes.
Your slides
So your slides are not moving.
stop करून share.
Slides are moving. Is it moving now?
No, sir.
Is it moving?
Still there is some
No,
problem.
no,
Still there
sir,
is
no.
some problem. Huh?
Okay, okay. Just I'll check.
Hello.
Madam. Hello, madam. Sir is doing the moving the screen now. Please
Network.
Manish sir will join in 2 minutes. Please wait for him. Manish sir is now working. स्लाइड मूव होत आहेत पण आवाज गेला आता. हो, स्लाइड मूव होत आहेत, काही प्रॉब्लेम नाही. Hello, dear participant. Actually, got some technical issue at Pune from sir side. Is trying to join the session in 2 minutes, and only 1 or 2 slides are remaining at the conclude slides. So please be patient for 2 minutes.
Hello. Hello.
Manish, you are audible. You are audible, Manish, sir.
Okay, okay. I'm very sorry for the inordinate delay in the lecture and all the technical problems that I'm facing because of the poor internet. I cannot show you the slide. Hello.
Yes, sir.
Hello.
Yes, sir.
Hello. Yeah. Yeah. So
Sir, you are audible.
we developed this kind of prototype. So we developed this kind of prototypes. One Scarlet Dimmer. We developed this prototype, established the technology, showed the technology to the industry, and then based on the results that we obtained, one industry came forward that is called as Ant Ceramics or Ant Innovative.
Sir, you are not audible. Manish, sir, you are not audible. Manish, sir, are you there? Manish, sir. पुन्हा लिव्ह झालायस तू. बरं बरं, मी एक काम करू का, नेक्स्ट सेशन सुरू करून देऊ का मग आता, चालेल का? चालेल चालेल. अरे नाही नाही, काय करणार तू, जॉईन हो ना, मग झालं तर जॉईन हो. चालेल, ठीक ठीक. Boer sir, are you there?
Yes, sir. Yes, sir.
Actually, I have talked to Dr. Manish in this, sir. There is a severe issue in the network and connectivity is there. Next session, we can call up our next invited speaker, Dr. Hanadi, sir. Please, sir.
Okay, so shall I thanks to Mr. Dr. Manish, sir?
Yes, sir.
Whether he's going to continue with us later on or what?
Actually, resolving the internet issue there, and I will let you know, sir. Please, we can continue the next session. He said, continue the next session, then I will get you back.
Okay,
Hello?
okay, okay.
Hello?
Yes. Yes,
Yeah,
sir.
I'm sorry for the problem. I think I stop here. I'm very sorry. I wanted to show some more results, but I think it's better to stop because of those problems. And I thank you again very much for giving me the opportunity to present my work.
Sir, thank you, sir. Thanks a lot. Actually, you are just listening your lecture is very informative and very interesting. Sir, from the whole team of our international virtual conference on material and nanotechnology, I'm thank you. I give very much thankful to you for giving such an introductory lecture, and very core technical work is there. And what I find is interesting is that is completely say useful for the society and industry based. You are doing the application there. Thank you, sir. Thanks a lot. And again, I'm thankful to you for giving us such a wonderful speaker, Dr. Ashok Joshi, sir. Without you, is not possible to have such a wonderful speaker, the inaugurator. Thank you, Manish, sir. Thank you again.
Thank you. Thank you, Manish, sir, for your stimulating speech in the international conference. And definitely your comment were especially helpful for those who are doing research here. Thank you, Manish, sir. Then now, today again we are having one James with her, and that is Dr. D. Harnath, sir. Here is the brief introduction of Dr. D. Harnath. Basically, he is associate professor in physics at NIT Warangal, Telangana, and before that, he was principal scientist in CSIR National Physical Laboratory, New Delhi. He completed his graduation from Andhra Pradesh Residential Degree College, Nagarjuna Sagar, with physics, chemistry, and math. Later on, 1992. In 1994, he completed his postdoctorate from Kakatiya University, Warangal, Telangana, with first rank and with 2 gold medals. In 1999, he completed his PhD from Shivaji University, Maharashtra, and the topic was sol gel processing and the characterization of silica gel and the glasses under the guidance of Dr. A. Venkatrao. After that, 1999, in 2000, since he worked as a research scientist in developing advanced luminescence material and the devices at CSIR NPL. Till after that, in 2006, worked as a postdoctoral fellow for 15 months at Nanocrystals Technology, New York, USA, for the synthesis and the characterization of binary and ternary nanophosphor for white LED applications. Sir received so many awards and the medals during his tenure. Basically, he is visiting scientist for the nano theranostics, New York, USA. From 2019, he will work till 2024. Second, the Transfer of Technology Appreciation Award in CSIR NPL in 2017. Fellow of Luminescence Society of India 2017. Viraj Distinguished Scientist Award in Physical Science 2016. Visiting Scientist for Nanocrystals Technology, New York, USA since 2007 to 2018. Visiting Research for the Pace University, New York, USA 2007 to 2011. DST's Boycott Fellow Award in Physical Science 2006. CSIR Young Scientist Award in Physical Science 2004. NPL and Young Scientist Award 2004. 2 gold medals award in MSc in 1999. University First Rank Award in MSc in 1994. And 6th National Science Foundation Day Awards in 1993. Sir having the very good teaching experience also, that is the 13 years of experience. 2 years of experience in Mahatma Gandhi Institute of Technology, MGIT, Hyderabad. Then after that, he taught nanostructure material to MTech and PhD students at Academy of Scientific and the Innovative Research, CSIR New Delhi, that is from 2010 to 2018. And after that, He worked at as a teaching photonics and the nanophotonics for MSc technology students, engineering and physics for the BTech since 2018. And along with that, sir, having the very huge experience of research and development. That the 27 years of experience he is having. Area of research interest, photonics, luminescence, nanomaterials, and the soil gel technology. Along with that, natures of R&D activities are development of primary colors, the RGB, long persistent phosphor for dark vision display application. Second, fabrication and the electroluminescence panels for backlight of LED panels. Third, synthesis and the characterization of nanophase luminescence material and the devices. Fourth, development of radioluminescence screen for high energy X-ray real-time imaging. Fifth, band gap engineering of nanophosphorus for white LED applications. Along with that, sir, having very huge data or the details of publications, number of CSIR journal till 2021 April, that is 190. That citation is 4642, H index 37, I index 101. So many actually, sir, here given data regarding his publication and other things. Transfer technology, industry one, and the government organization to patent granted or the 7 and the file 2 research grant completed 13 sanction 1 SCI index article published 190 accepted 1 Scopus index published 190 accepted 1 other indexes published 5 and the accepted. Sir, having received international awards also 3 and the national 9 awards. Paper presented in national conferences 170 and the international conferences 25. Invited presenters delivered scientific meeting 18, workshops 13, conferences 105, seminar 76. Sir, supervised PhD students graduated 7 and the current 2. Book authored with ISBN number. Book 1 and the book chapters are 7. Professional membership, international 1 and national 5. And the editorial appointment in the journal, editor-in-chief, associate editor, then the reviewer and the board member. In the 15 journal, sir worked as a reviewer and the 2 journal as a board member. And also having the reviewer for the international journals like the Applied Physics Later, Journal of Material Science, and the Chemistry C Material Letters like this. So here I welcome to Dr. Sir to deliver his topic. Thank you, sir. Arnath sir, please.
Good morning and thank you, Dr. Amul Bhoyer sir, for reading out my CV. Am I audible, sir?
Yes, sir. Yes, sir. Yeah.
Okay, thank you. Could you able to see my slides, sir?
Yes, sir. Yes, yes. Clearly, sir.
Okay. First of all, I would like to thank the organizers of this international virtual conference on materials and nanotechnology for giving me this opportunity to share some of my research work. Here I am coming up with a very new and very interesting topic, like extraction of latent fingerprints. Latent means invisible. Extraction of invisible fingerprints using afterglow materials for forensic applications. Like you might have seen many like CAD type of movies and serials in which you might have seen how the fingerprints have been taken in the crime scene and so on. So this is the topic of my talk today. And these are my credentials and email address. And this is my host institute, National Institute of Technology, Warangal. And this is our institute's website and department's website. And this is my own research interest and my own profile. So you can go to this website and have a look about our research activities. So let me introduce you some of the basic fundamental things about fingerprints. Okay, so you may be interested to know that before 1856, if there is a crime scene which is there, so fingerprints were not recognized as the evidence. Okay, it was in 1856 Sir William Herschel, who was a English chief magistrate in India, in the British India. So he was the first person to accept the fingerprints as one of the evidences in order to judge the culprit. And this is his photo. And this is the document, the judiciary document, where the police has shown this type of fingerprints, and with the help of this one, he has given the judgment. So you might have heard some of the things. You might have heard that only once during the existence of our solar system will two human beings be born with similar finger markings. So this was the Harper's headline, which was given in 1910. When this judgment was given, then people started thinking about these fingerprints. So you might have heard that no two persons will have same type of fingerprints. So same thing, it was put it in this wording. Okay, so even though the children are born to the same mother, or judua type of twins, even then they will have different fingerprints. So, and in the Scientific American also, they have done some scientific research, and they found that uh, two like fingerprints would be found only once in 10 power 48 years. So this is a scientific calculation they have done, and they could found that if somebody is having fingerprint today, the same fingerprint will be repeated after 10 power 48 years. That means almost impossible. But it was the thing in 1911. After this, people started using fingerprints obtained at the crime scene as one of the evidences, strong evidences for giving the judgment. Okay, so one thing you have to remember, there are three fundamental principles, like fingerprints are individual characteristics. Okay, so every individual will have his own fingerprints, and fingerprint will remain unchanged during the individual lifetime. So you might have heard that misconception, like children, they will have different fingerprints, and while they grow up, they will have different fingerprints. That is wrong. So everybody, so once it is fingerprints are there, only the magnification of the fingerprints will vary, but individual fingerprints never change. Even some people, they say that if you are cutting vegetables and all, if your hand is I mean palm is cut, then your fingerprints will change. No, it will be disrupted, there will be some distortion, but they will not change. And these fingerprints are unique, and these have a general characteristic of ridge pattern. I'll show you what are these ridge patterns, and under the ridge patterns again we'll have a sub category called minutiae. So these are the two things, they are very much essential, and those are the things that will differentiate each and every person. See, crores of people are there, but still we can find all the ridge and minutiae patterns are different for each and every individual. So these are the basic fingerprint patterns. There are four types of pattern, whoever it may be, an Indian or a foreigner. So everybody will have only these type of four types of fingerprints. So the one is called arch, means it starts from left side and it ends in right side with a small hump type of thing at this one. So these are called arch type of fingerprints. And the tent, it is similar to arch, but you will have a small a camping tent type of thing. Okay, so a more elevated type of sharp tip will be observed, so they will come and they will go. So these are the other pattern, that's called tent pattern. Loop are the one, these pattern have a ridges entering from one side and exiting from the same side, whether it is from left to left or right to right. And the fourth one is whirl. It's like a whirlpool type of thing. So it will have concentric type of circles, and and there are various other patterns. So these are the only four types of fingerprints that the mankind is having. But the thing is, it could be a combination of all the three, permutation and combination of all these four patterns that are available with every person. Okay, so the minute indications of these rich patterns, they are called minutiae. So large lines, they are called the ridges, and small segments that are associated like pores, cuttings, and then small overlap, loop type of thing, branching and other things. They are called the minutiae. Let me show you some of the commonly observed minutiae patterns. So for each line, so it is called bifurcation. Bifurcation, you see, it is like a channel, like road has divided like that. You have Y type of pattern here. So that's called bifurcation. This is a pores type of things that are observed on the ridges. So they are like small dots type of thing. They are encircled type of pore-like structures. So this is another type of minutiae. The other is scare. Scare means घाव लग जाता है ना. So some accident or something, if somebody faces, then the some unwanted lines will come up. So that is called scares. And hook type of pattern. It's like a hook, question mark type of thing. Okay, hook type of patterns are also there. And you can have some line fragment, like this is the black line is the line. So it has a small segment, like it has ended. So this is one end, this is the other end. Whereas in other cases, you see they are very lengthy lines, but here is a small segments, fragments of the line. And here is a eye type of pattern. So here you can see that it is like a island type of thing. Line is going on. The black one is the line. Okay, they are going on, and it is encircled like this, having an eye type of pattern. So you can have 6 types of minutiae patterns commonly observed. Okay. Now you have 6 minutiae and 4 basic fingerprint patterns, and the permutation of permutation combination of all these things will be there in each and every person. Okay, so it could be more branching, and it could be less branching, arch plus tent plus loop plus whole, or combination of 2 or 3, and along with the combination of these, so many permutation and combination may arise. So these are the basic fundamental things about the fingerprints. And you know that there are almost 150 individual characteristics that one can have on an average fingerprint. It's a average number. So a combination of 150 will be there on an average in a single fingerprint. But it is interesting to note that for the court to give the judgment, they if the police matches 8 to 16 combinations out of this 150, that is just sufficient to give the verdict. Okay, court can give the judgment. Not necessary that, oh, out of 150, around 50 should match or 100 should match. No, we cannot do that much. So only 8 to 16 perfect matching will give, the court can give its judgment. Now the thing is, out of so many things, how to find out or exactly match this one? Is it earlier they used to do manually, but nowadays there is a big software called integrated automated fingerprint identification system, which is there in the USA with FBI, Federal Bureau of Investigation. They are holding this thing, and nowadays the crime has become international. It's not regional. Okay, so what they are having is they are collecting all the information from the throughout the world, the criminal information, and they are dumping and making a master file, so that if a culprit in India, if he goes to USA and if he do some crime there, so they can easily identify that person. But having so many millions and trillions of these fingerprints and matching one a case or one fingerprint with that one, it takes months together timing. is it not? So even the computer, fastest computer, it takes so many months to do that. So what they do is they categorize it to different segments like Asian, African, American, North American, South American, Australian, like that they bifurcate. And out of this, again they bifurcate into the various countries. So if they identify that the person is from so and so country origin, so immediately they can search in that small segment itself. So that gives many other things. And you know that new and new uh, uh, criminals are coming up in every country. So they are updating these things, and they are scanning and keeping all that minutiae and rich patterns in their database. So that's how they are doing. And using this also, if 8 to 16 are matching, then court is happy with that one. So all these things are very much important nowadays. So there are different types of fingerprints we can observe at the crime scene. Okay, so we can have one type of fingerprints called patent prints. Patent prints means permanent prints. Like if the print is observed on a colored material or a blood stain, okay, on the wall, or something on the paint or grease or ink. So they are almost they are permanent, like it is difficult to erase them out. So they are, and they are easily visible. They are called patent prints. And the other called plastic prints. Plastic prints mean temporary prints that you can have it on some putty like of substance, some glue type of things, okay, some wax, or fingerprints on the soap, or on the dust particle, on the dusty surface if you have fingerprints. So they are called plastic prints because they can be easily erased, you can deform them. And the third one is called latent prints. Latent prints means invisible prints. So these things are visible, so the culprit or the criminal, what he can erase them, he try to modify it, he try to erase these things, or he will try to erase these type of things. But latent prints are those prints which are invisible to the naked eye. So they can be on a newspaper, or they can be like how do you get these latent prints? If the crime doer, if he is there, so automatically uh, he because of that, because of anxiety, he may have more precipitation, more sweating. So the sweating, the perspiration, which contains the water, salt, amino acids, oils, that it contains in his sweat, so that may be casted on some of the surfaces, like maybe on the glass surface, or some wood, or some porous materials, or wood, something. So these things are invisible, and this fellow cannot clear them up. So there are different techniques with which we can elevate that, those latent fingerprints, and we can uh, capture photographs. So those can be evidences, can be produced in the court of law. So as I told, that patent and plastic prints are visible and they can be altered, whereas latent prints are invisible. And with using chemical and physical processing, we can lift them, we can make them visible and take the photograph. Because you know that cases, they run for many years. Okay, so you need to preserve these things. You cannot leave the scene like that. You have to take photographs of that one. So how do you select for developing these fingerprints? So which is the method with which we can do? So both, I told that physical methods and chemical methods are there. So physical methods can be used on dry materials or dry surfaces, non-porous surfaces like glass, plastic, and so on. So if the latent prints are available on dry, wet surfaces, or on paper, porous surfaces, okay, cloth, cardboard type of materials, there it is very difficult to take out the invisible fingerprints. There some chemical processing techniques are required. So these are the non-porous surfaces where you can have the physical methods that we can do, and these are the porous surfaces like fabric, paper, unfinished wood. So there we can do some chemical processing to lift out those fingerprints. So what are the methods of developing these fingerprints, whether it is a chemical or physical method? So what we can do, the famous thing is called powder dusting method. So powder dusting, they use like iron oxide or some aluminum powders or some organic dyes, pigments, they use it. So these are the things they spray, and even they use some of the luminescent materials, fluorescent materials, they spray on certain surfaces like glass surfaces. If that criminal has caught hold of the some glass or drinking glass or table or somewhere, so they spray, and then so that will develop these things. Okay, so there are some chemical fuming techniques. Suppose you cannot spray powders, and what you can do on the porous materials, like you can do iodine fuming, cyanoacrylate fuming, some fumes can be put. That fumes will have a chemical reaction with the fingerprint, and the invisible fingerprint will be seen. So these are the various other binders people use to extract these fingerprints. And there's another technique called vacuum metal deposition technique, which is very, very costly, and only high profile cases only they use. Actually, this is the technique with which you can lift out the latent fingerprints observed on cloth, fabric. It is very difficult. Now people may think that it is very difficult to take it out, but usually they use zinc type of materials, powders, to lift, but zinc doesn't combine with the fatty acids that are present in the sweat. So what they do is they use a combination of gold and zinc. Okay, so if you use that one, it's a very vapor deposition technique. So it's a very costly technique, unless if the criminal doer is very intelligent, and he eliminates all the powder dusting and chemical fuming, and if it is a high profile case, then only they will go, police will go for this type of uh, very sophisticated technique. So one of the techniques is using magnetic powders. So magnetic powders, suppose if the fingerprints are casted on leather or some rough surfaces, they put the magnetic powder over the surface, and below the bottom of the table they keep the magnet, strong magnet, and they just align these particles. So wherever the sticky region is there they will stick, and that forms the fingerprint. Suppose if it is on fingerprints are casted on paper, let us say porous materials like paper or cloth. So ninhydrin is another chemical, one can use it. So it reacts with the proteins that are available in the sweat, and it changes the color. So it gives out like these features. So this is also very interesting and very useful technique with which we can find out these fingerprints, so invisible fingerprint. Similarly, cyanoacrylic esters also, they are used on some polymers and other thing, transparent polymers and so on. So there you can use this ester and take out the fingerprints. And the iodine technique is another technique where you can use iodine vapors. You can put the iodine crystals and heat it, and put the specimen, so where you may feel that there is some fingerprint associated with that one. Or you can lift out that fingerprint using a tape, cello tape, and then hang that cello tape and use the iron, you melt and vaporize it, so in a closed chamber, so it will show up this type of visualized things. So these things can be easily photographed and preserved, and high resolution photographs they can take, so that they can see the minute patterns also in that one. So as I told that the using physical techniques, so luminescent materials or the fluorescent materials are also can be used for lifting. Most of the time they use organic dyes and other things. So organic fluorescent dyes like rhodamine B, is in yellow, and many other things are used. Okay, but you know that the organic dyes have a limited tendency or limited lifetime, so they bleach out with time. So if you put such type of fluorescent dyes, okay, and immediately if you take photograph, it's okay. But if the court after few years, if again they wanted to see or do that one, then everything will be lost in that case. So there are some up conversion phosphors. There are also some interesting fluorescent materials. So usually you give ultraviolet or any other high energy radiation, then it will absorb and it will give out the visible light, which is called down conversion. But on up conversion means you shine instead of ultraviolet, you shine very low energy infrared radiation. So it will give the visible radiation. Only lasers of such type, when the IR lasers are shined on these materials, they give out that type of coloration. This is the newest advancement in this fingerprinting technology. And apart from this, fluorescent inorganic phosphors. Okay, phosphor is nothing but a luminescent material. So inorganic luminescent materials of various kinds can be used to take out those fingerprints. But all these cases, okay, the lifetime of these materials are very, very less. And the problem is, suppose the fingerprints are there on any colored surface or already fluorescent substrate, and if you shine ultraviolet on that one, the background emission also will be there from the substrate as well as the fingerprints also. So there is a chance that you will lose much information. So maybe some overlap of colors may lead to misleading of the case. So here is the solution for that. So if you use a phosphorescent material, phosphorescent materials are the materials which absorbs natural light and then they store up, and in the dark, in the completely dark conditions, it will glow. So, and they are very inert inorganic materials. The importance of these materials are you can have rapid visualization. Not only that, even the surface is giving the background fluorescence. You can just excite this material under sunlight or under strong room light and then keep it in the dark. So the background fluorescence will disappear and only the material which is attached to that fingerprint, that will glow. So that will not destroy the fingerprint and that will not react with the chemicals that are there in the sweat. So autofluorescence of the background you can eliminate. You can have rapid visualization. You can have very colored substrates also. No problem. We can take the fingerprints and very high contrast fingerprints can be obtained. So let me introduce this phosphorescent materials or the long afterglow materials. These are the special kind of materials which are excited by room light, sunlight, ordinary light, and no continuous supply of ordinary light is also required. Few minutes you can give, and it is a non-hazardous, non-radioactive, rechargeable materials. Just shine sunlight or ordinary light for 5 minutes, and that will glow for many hours. So continuously it can glow. This is a watch where we have quoted in NPL and just put for 5 minutes in normal room light, and the night you can see the glow like this. So you can continuously glow in the dark for about 10 to 15 hours. So the advantage of this one, these type of materials can be as a source of light in extreme dark conditions. You can identify objects. You can put this type of stickers on the switches so that when you enter into the dark room, you can visualize the switches and you can put the switch on. And escape route and guidance systems also you can use it. Like whenever there is a sudden power failure, you can have the escape route showing arrow marks, warning signs, special effects in bars and discotheques. So consumer products like switches, watches, ceramic tiles, and even nowadays you are getting in mobiles and remotes also. So these are the materials that are very useful in day-to-day life. And if you see the history of this long afterglow materials or the phosphorescent materials, it was way back in 1609, people could find out the ore of Bologna stone, which is barium sulfide, which was excited by sunlight in the daytime and nighttime it glows like this. And later on, people have developed zinc sulfide copper, which shows green emission, and many other sulfides they have tried. And they thought that only sulfides can show this type of behavior for a few hours because they are readily excited by sunlight. But main disadvantage with the sulfides is they are chemically unstable. When it is exposed or when water falls on that one, it releases H2S gas and they decompose to zinc sulfide will decompose to zinc oxide and so on. So and later on, after Second World War, in 90s, Matsuzawa, a Japanese scientist, when he has developed some oxide-based materials with very long, dark, persistent time. In the dark, you can see these many hours. Then people started thinking that, okay, other than sulfurs also one can make such type of materials. And we also made many materials of this kind at CSR NPL and at National Institute of Technology, Warangal. So they can excitable by room light, and if you switch off the room lights, then they can glow in the dark for many hours. We have developed red, blue, green. Only green you might have seen in some of the trains and aeroplanes, but we have developed blue which can glow up to 8 hours and red up to half an hour. So these are the various materials which we have developed, and we have quoted on various articles just to show that uh, they are internationally accepted. And even the NPL auditorium, we have replaced the normal exit signages with this one, so that if there is a power failure, so you can see the exit at the door. So, and not only that, we'll be always comparing our product with the best phosphors and Chinese phosphor that are available in the market. And you see that NPL phosphor or R phosphor is much better compared to that one. So all the three colors we have developed and we have patented, and for green, we have transferred the technology also to the industry. So how to generate this type of afterglow or the dark glow luminescence? So there are various types, like you can create defects, or you can code up with the trapping centers, or defects you can create, extended defects, or energy transfer mechanism. These are the various mechanisms with which we can do it. In this case, we have used a code open system, so that will trap the holes, okay, in the energy level diagram. When it is excited with normal light, electron go to the higher energy state and holes are being captured. Until and unless hole is seen, there is a recombination, you cannot have the glow. So there is a slow release of holes, and slow recombination will give very long period of luminescence. So maybe in the introductory, in the plenary talk, Professor S.J. Doble might have already told you about the various methods of synthesis. So I'm not highlighting that one. So this is a simple chemical technique with which you can make this type of materials using auto combustion process we did, and you can make these materials and glow in the dark. So these materials, when you can easily crush it into fine powder and use it in some of the transparent paints, and you can use it. So let me skip all this characterization, other things. How it will be useful for fingerprints, let us go to that. So these afterglow phosphorescent materials have many applications. Some of the things like warning signals, okay, signages, okay, structural damages, and some of the luminescent markers in biological systems, structural damage in metallic things. All these people, photocatalysis, many things people have already seen, except forensic science. So we wanted to use this material for this one for the first time. So what we did? So first, what we have started doing is collecting the chemical composition of sweat, because sweat is the one which will cast the fingerprint. So if you know what are the constituents of the sweat, whether our material will react with that one and it will lose its fluorescence or phosphorescence, first we have to understand that one. So we have studied the various things at the crime scene, and what are the implications on inorganic constituents and other things we have studied. And after that, we have seen that our phosphor, that luminescent material called strontium aluminate, we have named it as SRA. So that we have put it with this sweat residue and started analyzing whether there will be chemical reaction and losing of some intensity or so. But fortunately, there was nothing. It was not at all losing. So all the chemical reactions and everything we have studied, and we could see that our material did not degrade with that one. So with the help of that one, then we started taking various substrate, like here a plastic cup was taken, and fingerprints were casted, which are invisible on a plastic substrate. So if you spray our long afterglow phosphor on that one, so it will be like this, but it is still invisible. But if you put under sunlight for some time, or you shine some ordinary light on this for some time, then in the dark you see completely, you can see the glow. Otherwise, if you would have used a normal fluorescent material, if you keep this one and the whole cup under ultraviolet light, whole plastic will glow with a strong blue coloration and this green, and everything will overlap and you will not find these fingerprints. So these fingerprints can be captured with a high resolution camera. So these were the things one can do it. Not only that, what we did, we have applied this on various substrate like glass substrate. On a glass surface we have done, and on glossy paper we have done, and porcelain, chinimity, cups and other things, aluminum foil, many other substrate, and like non-porous substrate like PET substrate, uh, plastic substrates, porous and non-porous PET substrates, porous and black colored paper. So many other substrates, and everywhere we are successful in taking out those fingerprints. Of course, these are not the fingerprints of any criminal. This is the fingerprints of my own student. Of course, for publishing this paper also, we had a lot of trouble because the editor asks for various ethical things, whether this is really from a police history or this fellow is having some criminal history. So in order to publish this paper, they are very reluctant. So we have given all sorts of declarations and other things, and even the student has to give declaration that without my force, the guide's force, intentionally they have given these fingerprints and so on. So here you can see the scars, cuts, because this is given by a girl. Maybe there are some cuts that are there when she was doing vegetable cutting or so. I don't know. So there's some scars are also there on that one. See overall fingerprint patterns, and you see that autofluorescence of the background we have suppressed. Okay, there is these are the autofluorescence. You can see here. You see a lot of background illumination and this illumination. But when you put it under dark, you can eliminate the background, and only this thing can be captured. So many contrast, many other important things, and these are non toxic material, and there is no reaction for that, and you can keep it for many years. Not only that, here we have enlarged and we have seen the bifurcation, which I told, like Y type of bifurcation. Okay, ridge ending. There is the end for the ridge, enclosure. Okay, some scars, cuts. So other with other colors also we have seen, because every time we cannot use blue color, green color. We have to go for different colors to take out those things. So we have developed various materials and we have done. And this is there are different levels with which we can identify this one. The level 1 features the ridge orientation. This is the overall pattern we'll see, and level 2 will go for the short ridges or the bifurcation or porous structures and so on. Those are the enclosures that they will enlarge and they will see. The combination of these two will give better understanding of the persons and his identification. So this was published by my student G. Swati, and we have published in this Royal Society of Chemistry journal, where I told that a lot of things, so a lot of declarations we had to give. Finally, we could publish, and in the last year also we could publish another paper in that one. Finally, I would like to thank all my past and present students, those who are working at CSR, NPL, and NIT Warangal, and I would like to thank the organizers of both Guru Nanak College of Science, Ballarpur, and PR Pote College of Engineering and Management, Amravati, for both of all the office bearers and organizers of this conference, both teaching and non-teaching staff, everybody, principal, chairman, president, everybody. I would like to thank for giving me this opportunity, hoping that I have not exceeded the time. And these are the various products which we have developed in our laboratory in various substrates, beads and lamps and so on. And some are taken from the internet. There are many applications associated with that. And not only that, in 2016, we are successful in transferring the technology of these materials, okay, to a paint industry called Messrs. Catline Infra Products Private Limited, Nagpur, and for a phenomenal amount of only for one color, we could sell it for 11.50 lakh rupees. So this is the achievement, and they are in need of various other colors, blue, green, orange, red, and so on. So we are in the process of developing that, and a few more PhDs are also lined up there. So I once again I thank you all for your patient learning, and I'm happy to answer some of the questions the audiences are having. Thank you very much. Yes, sir. I'm happy to answer the questions. I'm not expert in forensic science, but the thing is, only with the development of these materials for various applications, we could take that one and use it for a novel application. That's the thing we have done for this.
Anyone from you people, if you are having any query or want to ask anything, you can ask.
Hello.
Yes, madam.
Sir, I wish to ask because initially your PhD is in Solgel, aerosol. So how you change your focus from that sector to this?
Madam, I am like a butterfly. I change fields, many fields. See,
Yes.
it will be, see, that is the right question that I have worked on sol gel glasses and aerosols and aerogels. Okay. So that is for my PhD. But when I went to CSR NPL, there was nothing like sol gel lab or something that was existing. So I had to work in certain other area. So I was open for all the type of research. So I have worked on that, and after that I worked on thermoelectric materials, organic solar cells, inorganic solar
Okay.
cells. So if you
Okay.
see my research profile of 190 publications, you may end up having 10 to 10
Yes.
research topics.
Okay. Thank you very much, sir. Thank you very much, sir.
Thank you.
Okay, thank you, sir.
Thank you, Amol sir. Thank you very
Okay,
much.
thank you.
I can
Yes,
take
sir,
it.
please accept our sincere appreciation for outstanding presentation, sir, you made. And thank you so much for sharing your time and experience with us. Thank you very much, sir.
Thank you, sir.
Now, here we are having another James who is going to share his experience and work with us. So I call uh, Konstantin Ivankovich, sir. Basically, he completed his PhD in physics from Rural State Technical University, Russia. Specialization was physics of condensed matter, and the PhD topic was excitation and the relaxation of high energy state of rare earth icon doped with strontium fluoride crystals in 2006. He completed his engineering as a physicist in Rural State Technical University, Russia in 2002. Uh, Specialization was electronics and automation of physical plants. Sir, having so many areas of expertise. First is luminescence and optical spectroscopy of solid state nanomaterials, spectroscopy of lanthanide, that is rare earth ions, fast scintillators material for medical imaging, phosphor for LED and display application, luminescence concentrators, VUV emitting optical materials, host to impurity energy transfer and dynamic of host electronic excitations, defects trapping state and impurity trap excitons, photoionization of impurity centers. Also in synthesis and the structural characterization of optical nanomaterials, and along with that, laser induced microwave photoconductivity. Sir, having the so many appointments since year, since 2002, basically from 2002 to 2004, he worked in a department of experimental physics, rural state of technical university, Russia, R&D, development and testing of gamma and the neutron radiometer and the spectrometer. After 2004 to 2006, he same worked as a instructor of physics and the technology, teaching practical courses, that is detection and the ionizing radiation and the spectrometry, and the digital and the impulse techniques, supervision of students research project. Before that, I'm sorry, after that, in 2006 to 7, he worked in a same here in a rural state technical university as a running reading course, programmable logic devices, solid state physics partially, the practical course, and the detection of the ionization radiation spectroscopy. After that, 2007 to 2009, DB Institute for the Nanomaterial Science, Netherlands, postdoctoral research in synthesis and the characterization of new ultra-fast scintillator material for the medical imaging, TOF, PET, and the CT scanner, time resolve VUV spectroscopy for lanthanide doped inorganic crystal, ceramics, and the nanopowders, spectroscopy with the synchronous radiations. 2009 to 2010, Sir worked in the Institute of Libre Madrid, France, time domain study of transit response of the laser induced photoconductivity. 2010 to 2013, worked in the Department of Physics and Astronomy, University of Canterbury, New Zealand, as a postdoctoral research. 2013 to 2020, Sir worked as a ANK Service, Russia, Director of Research and Development, the setting strategic direction, determination, goal, objective of the multidisciplinary team of researchers. And since December 2013 to till date, Department of Experimental Physics, Rural Federal University, Russia, as a senior research fellow. And along with that, January 2021, he is State Research and the Design Institute of Rare Metal Metallurgy, Rosatom, State Atomic Energy Corporation, Russia, as a Deputy Director of Research and Innovations. Till date, he is working. Sir, having the awards and the recognitions that elsewhere, optical material certificate of outstanding contribution for 2017 and 18, Academic Council of Rural Federal University Award of Excellence in Research 2014, the first President of Russia Award for Young Researchers Excellence in Research Prize 2004 and 2006, Academic Council of Rural State Technical University Award for Excellence in Research 2004 and 2005, Rural Research and Education Center for Advanced Material Award for Excellence in Research 2003, Scholars to Outstanding Postgraduate Award by Rural Research and Education Center for Advanced Material, US Russian CRDF program 2002 and 3. Very great achievements are having. And along with that, Sir also worked in some professional services where the referee for the Journal of Molecular Structure, Journal of Luminescence, and optical material like this, Journal of Alloy and Compounds, professional affiliations having the European Rare Earth and Actinide Society, American Society for the Testing and Material ASTMs, and having along the very high list of the selected publication. So here I welcome uh, Constantine sir to deliver
Hello.
his topic.
Hello. Hello. Thank you for introduction. Sorry. Thank you for introduction. Can you hear me perfectly? So I will share my presentation. Just a second. Okay.
Hello.
Okay. So can you see my presentation?
Yes, sir. Yeah.
Okay. Okay. So hello everyone. My presentation today concerns radiative and non-radiative relaxation process in lanthanide doped luminescence materials. And I should note that we will focus on inorganic insulator materials, which currently dominate in commercial applications of luminescence materials. So most of the research was performed at Ural Federal University. It's a university in Yekaterinburg. I just thought which photo I should show for Indians, and I decided that the photo with image with snow would be most impressive for Indians. So this is our university in winter. Here is my email address and web address of our university. At the same time, I also share a position in Rosatom Atomic State Corporation, and where I'm working for governing research in array of materials and metals. So first, I should emphasize the importance of subjects we are going to discuss today, and I'd like to remind you about main directions for application of lanthanide doped luminescence materials and energy used to excite them. Applications of visible and UV excited materials include light emitting diodes, solid state lasers, fluorescence lamps, materials excited in vacuum UV range are widely applied in display technologies, mercury-free fluorescence lamps, neon tubing, tunable UV-VV solid-state lasers. And finally, an important class of materials is used to convert ionizing radiation such as X-ray or gamma rays into visible light. I mean scintillators and X-ray phosphors. And I will just shortly demonstrate you one of the most important applications and most challenging application for scintillators that is related to positron emission tomography that requires many issues related to light yield, decay time, and some of them quite extreme, like fast decay time, which should be less than 30 nanoseconds, short rise time that is should be less than 500 picoseconds, no afterglow, and high density of materials and high energy resolution. And so it's materials for scintillators should be efficient and provide good timing for detection. And when we talk about relaxation process and energy transfer in lanthanide doped luminescence materials, depending on energy of photons used to excite luminescence material, we may deal with longer or shorter, more or less complicated sequence of relaxation process, which are shown on this scheme. The scheme represents valence and conduction bands separated by forbidden gap, where we find energy levels of dopant ion, and that can be a lanthanide, and different traps. So for materials excited with ionizing radiation, relaxation processes include generation of primary electrons and holes in elastic electron scattering and Auger processes, leading to multiplication of electronic excitations. And further electronic excitations lose their energy during thermalization stage that may be followed by self-trapping or capture by traps. At the same time, electronic excitations may transfer energy to dopant ions and excite them. The efficiency of the energy transfer is determined by many factors, which we'll consider very soon. And further, the excited dopant ion may decay radiatively or non-radiatively, and there is also a chance that excited ion will decay. So it may transfer energy to defects or something. So let's continue. Before we continue, I want to dwell on some experimental issues. So most of the research we performed to study luminescence materials, we performed using synchrotron radiation facilities. So depending on your purpose, you may need to record emission, absorption, excitation spectra, and it is also useful to study dynamics of relaxation processes. And in this case, you need to measure you need to perform lifetime measurements or emission time profiles in general. So, and for the last 20 years, most of the experiments we performed setups listed on this slide, and each setup has its own set of advantages. And so we mostly work at DAISY synchrotron in Hamburg, in Germany, and at Advanced Photon Source in Argonne National Laboratory in US. Some experiments were performed at Butker Institute of Nuclear Physics, at Web3 Storage Link in Russia. And recently we started our experiments at BSRF synchrotron in China. So our tools include mostly UV, VV spectroscopy, and here is a sketch of and parameters of superlumi setup located at DAISY synchrotron. Now it's closed, and this setup is transferred to another storage link, that is Petra free storage link. But we will continue using this setup, which will be modernized in the future. So this is probably one of the this probably was one of the most sorry. This probably most sophisticated setup in the world, which allows studying the above mentioned characteristics in UV and vacuum UV range. And here is a sketch of parameters of luminescence setup at Butker Institute of Nuclear Physics in Russia. It allows to perform time-resolved luminescence spectroscopy upon excitation with X-ray photons, and you can record time-resolved spectra within six time windows. So now we are going to look at relaxation processes related to the host. So you have basically one of the most effective ways to transfer energy is when electron and hole recombine on dopant ion. And this may happen via sequential capture of electron and hole. So for example, cerium free plus ion can be easily oxidized and become cerium 4+ after trapping of hole from the valence band. So this is followed by capture of electron and formation of excited cerium 3+ ion, which further decays radiatively. And Coulomb interaction between electron and hole may cause formation of a free exciton, which may further relax into self-trapped exciton. And the free excitons are very mobile and they can travel through several lattice constants during their lifetime, which is shorter than 10 to the power minus 9 seconds, even at low temperature. So, in contrast to migration of self-trapped exciton in the lattice, Hoping diffusion mode, it may also migrate for Hoping diffusion mode, and but because of their longer lifetime, migration range is approximately of the same order as for free exciton. Average distance covered by exciton in lattice is approximately 10 nanometers. So it's it corresponds to average distance between two dopant ions when concentration of impurity is about 0.5%. So besides, self-trapped excitons may decay radiatively and produce emission, which can reabsorbed by dopant ion. And in this case, we deal with radiative energy transfer. So the main factor that determines probability for excitons and carriers to be captured by dopant ion is connected with location of its energy levels relative to conduction band. For example, ground state of lanthanide ions are located closer to the top of valence band in oxides, while in fluorides they are located at much higher energy. Obviously, in the second case, the capture of a hole from the valence band is energetically unlikely. So this is often in favor of excitonic energy transfer. And I want to draw your attention to the fact of location of ground state. The location of ground state is different for different lanthanide ions. That may also greatly affect probability for the capture of carriers. So this can be nicely demonstrated by example of excitation spectra recorded for free ions, neodymium, praseodymium, and cerium doped in yttrium lutetium phosphates, which are basically very the same host. So diagram, the diagram on the top here, constructed by Peter Doornbos, it's a researcher from Netherlands, demonstrates location of ground states for trivalent lanthanides. So in this example, excitation spectra recorded for neodymium and praseodymium demonstrates behavior which is typical for energy transfer dominated by recombination mechanism. In case of cerium, however, ground state is located about 4 electron volts above the valence band. That makes recombination energy transfer less probable. In this case, we observe well-pronounced excitonic maximum, and this suggests that excitonic energy transfer dominates in this case. In some compounds, it is possible to observe the formation of self-trapped excitons, self-trapped holes, which may also transfer energy to dopant ions, either non-radiatively or non-radiatively. And this kind of energy transfer is usually quite slow and temperature dependent, as long as some thermal energy is required to activate migration of self-trapped holes. So, here I present some examples of excitation and emission spectra observed for barium lanthanide phosphate doped with cerium 3+. It's a quite effective scintillator that demonstrates energy transfer due to excitons. And you can see that undoped material demonstrates emission spectrum related to excitons. And if we record excitation spectrum, it just demonstrates excitonic peak at about 7 electron volts. And when we dope it with cerium, it demonstrates usually, so obviously excitonic emission is suppressed because excitons transfer energy to cerium 3+, and we only observe emission from cerium 3+. So, so basically we demonstrate efficient energy transfer from the host to cerium, and that is favored due to good match between intrinsic exciton emission and cerium 3+ for F5D absorption. And another interesting mechanism for energy transfer is effective when concentration of dopant ions is quite high, so usually above 1%. Above 1%. So 5D states of lanthanide ions may be directly excited by hot electrons when their energy relative to the bottom of conduction band is higher than energy of FD transitions. And please note that in this case we deal with multiplication of electronic excitations, as long as electron left in conduction band after energy exchange can be further captured by another cerium 3+ ion, or get bound with a hole and form an exciton. So have a look at this graph, that shows excitation spectra for cerium 3+. You can see that that from about 11 to 13 electron volts, excitation spectra recorded at helium and room temperature demonstrate well-pronounced increase, increase that is connected with electron impact excitation and multiplication of electronic excitations. So it happens around 12 electron volts. And you probably know that in many cases, internal defects in optical materials hamper energy transfer from the host to impurity. However, in some materials, defects may participate in energy transfer. In such a case, electronic excitations are effectively trapped by internal defects, which may further transfer energy to the dopant ions via radiative or non-radiative mechanism. And here is an example that I want to demonstrate you. Emissions, here you can observe emission excitation spectra and excitation spectra for cerium praseodymium ions doped into calcium lutetium double phosphate. So this material demonstrates intense emission of defects, which at least partly attributed to disordered nature of the host. The defect emission band nicely coincides with absorption of cerium 3+, that is in favor of energy transfer. And in case of praseodymium, the 5D states are shifted up towards higher energy for about 1.6 electron volts. And in this case, the defect excited states are likely to relax without transferring energy to praseodymium ions. So we don't observe energy transfer from the host and from the defects to praseodymium. And the last but not least mechanism of energy transfer I want to show you today occurs in lanthanide compounds. So quite often such compounds contain lanthanide ions in trivalent form, and in this case lanthanides may be optically active, efficient, and may efficiently trap electronic excitations and transfer them to the dopant ions. This process, however, is often slow and may cause buildup in emission time profiles, in emission decay kinetics of dopant ion. And here, this can be nicely demonstrated by two well-known scintillator materials. It's gadolinium oxy-orthosilicate doped with cerium, and lithium lutetium fluoride doped with cerium. And the first one contains gadolinium as host element, and the second one contains lutetium. So in the first case, host electronic excitations are mostly captured by gadolinium-free plus ions, which become excited within 4F configurations. And because of high concentration of gadolinium, energy can migrate from gadolinium sublattice and transfer energy to cerium-free plus. In case of lithium lutetium fluoride, the situation is a bit different. In this case, bottom of conduction band is dominated by 5D states of lutetium-free plus, and while 2S states of lithium are situated about 2 electron volts higher in energy. And in this condition, quite stable host electronic excitation can be formed with electron components either on lutetium states or on lithium states. And employing methods of UV spectroscopy, we can selectively excite lithium or lutetium states in conduction band. And as you can see on the right scheme here, we can selectively excite. So we can excite 4D states of yttrium or 2S states of lithium in conduction band. And when we go through this range, we can observe different time response for cerium emission. So basically, we can excite directly cerium-free plus directly. We can excite cerium-free plus states located in the conduction band, and we can excite conduction band states. So and these things, and so when excitation energy corresponds to interaction of excitation of cerium-free plus decays. So when we directly excite cerium-free plus, it's about when we excited about 5 electron volts, 6 electron volts, the decay curve is single exponential. But for higher energy, when we excite above 7 electron volts, and we observe ionization of cerium, and in this case we observe some buildup and appearance of slow decay components. And for electron behavior driven by Coulomb potential and diffusion process, we used the Onsager model that suggests the presence of critical radius for so for electrons distance from ionizing center, we can see that probability to recombine with the center, and this recombination resulting in creation of excited state is considered instantaneous. Usually, if electron is within the radius, within the crucial radius, but if electron migrates further from the radius, probability of recombination with the geminate center decreases inversely to the distance from the ion. In this case, the drift towards the virtual black sphere is controlled by diffusion, and recombination is delayed. In all other cases, the electron escapes its geminate ionizing center and can recombine with another aligned ionizing center, so it would be non-geminate recombination. And interplay between geminate and non-geminate recombination is manifested as a rise time and slow component in fluorescence decay of the probe of the ion. So I hope you can still follow me. Now I would like to draw your attention to the factors which may limit the efficiency of energy transfer. First of all, I should mention defects. Generally, defects may capture electrons, electronic excitations, and then relax non-radiatively. In some cases, shallow electron traps may cause delay in energy transfer. And secondly, localized electronic excitations such as self-trapped excitons, self-trapped holes may decay radiatively without sensitizing the dopant ion. And the next factor is low mobility of electronic excitations. This is especially true for materials where energy is mostly transferred by self-trapped electronic excitations. Another important factor is connected with migration losses due to separation of the components of electron hole pairs, which increases with rise of their initial kinetic energy due to increase of exciting photon energy. And finally, I actually didn't put it on the slide. I should mention the interaction of closely separated electronic excitations, which may be produced at high density of excitation. So before finishing with this part of my talk, I'd like to quickly take a look at process which may be important when we consider nanoscale materials. And first, we need to keep in mind the high surface to volume ratio. That means greater preconditions for perturbations related to surface related states or defects. And the second concern is related to diffusion lengths of electronic excitations, which is about the size of nanoparticles. And another important factor that is often forgotten in VV spectroscopy is elastic scattering of UV VV photons on nanoparticles. Graph on the left, spectrum on the left show excitation spectra recorded for lutetium aluminum garnet doped with praseodymium. It's a modern scintillator that we studied. You can observe excitation spectra recorded for micro-sized and nano-sized particles. And it can be seen that in case of nanopowder, efficiency of energy transfer from the host is much lower. That is probably related to surface quenching of electronic excitations. However, I should note that in some cases it is possible to observe very efficient energy transfer in nanoparticles. It is well demonstrated by excitation spectrum for nanopowder of lutetium oxyotosilicate doped with praseodymium. And in this case, we observe very efficient energy transfer, and in this case, it may be explained by the fact that crystal structure within a nanoparticle is nearly ideal, and electronic excitations migrate without significant energy losses, like in a single crystal. And we suppose that in this nanomaterial, dopant ions segregate on the surface of nanoparticles. And in this case, electronic excitations reaching the surface are efficiently captured by praseodymium ions. So, and here we will briefly consider calcium fluoride, cadmium fluoride superlattices, which are structures formed by periodic combination of monolayers of materials having different band gaps. And so basically they represent a sequence of quantum wells and barriers with modified optical properties. Such superlattices are of interest due to their potential application as resonance tunneling diodes and quantum cascade lasers. So luminescence properties for these materials are largely governed by behavior of cadmium fluoride quantum well. And due to its smaller band gap. And you can see excitation spectra for exciton emission in bulk cadmium fluoride crystals and in superlattice, and you can observe significant up to 1 electron volt blue shift of cadmium fluoride fundamental absorption that is related to confinement of non-relaxed excitons. So it's quite impressive confirmation for confinement of carriers in superlattices. And here, I also want to show you some results which we recently obtained for barium gadolinium fluoride doped with europium 3+ nanophosphorus. And this work was performed with my Indian collaborators. And so we synthesized, we used task-specific ionic liquid assisted synthesis to produce nanophosphorus. And here we observe temperature-dependent quantum cutting in these materials. And this is actually well-known quantum cutting in europium 3+ ions when we have quantum cutting upon excitation into gadolinium 3+ sublattice, and you have further energy transfer to 5d0 state, and basically relaxation of 6p state produce another photon. So you have actually quantum cutting in our materials. We had quantum cutting efficiency of about 120% and 160%, depending on using ionic liquids for synthesis of materials. And using of quantum cutting materials, you probably know about this. Using of quantum cutting materials is important in many applications, especially for solar cells converters, so to increase efficiency of solar cells. And now we are going to discuss relaxation processes which occur within dopant ion. And as you know, many relaxation processes occur within a dopant ion are commonly explained with the configuration coordinate diagram. The diagram is based on potential curves, which are plotted in a harmonic oscillator approximation. And each curve represents the total energy of the system in its ground and excited state as a function of the metal to ligand distance. And such a simple model may explain a number of effects, such as Toka's shift, which is measured as a difference between the maximum of absorption and emission parabolas. Electron lattice coupling is quantitatively characterized by Juan-Ariz parameter, which can be obtained if we know the Stokes shift. So in fact, Juan-Ariz parameter is a measure of the Stokes shift. And in case of weak coupling, when the parameter is zero, when Juan-Ariz parameter is zero, it's a typical case for zero phonon lines, and zero phonon lines are often observed in when we have 4F transitions. And in case of intermediate coupling, I mean 4F transitions in lanthanides. In case of intermediate coupling, zero phonon lines are also observable, but they are accompanied by vibronic side bands. And the case of strong electron lattice coupling is characterized by broad bands of Gaussian shape and in emission and excitation spectra. So it's the Gaussian shape is typical for excitons, for example, or defect emission. So, and one of the most important non-radiative relaxation mechanisms is thermal quenching. And when centers of two parabolas of two potential curves are shifted relative to each other, that means Juan-Ariz parameter is larger than zero, we may observe crossing two parabolas at some point. And in this case, an electron in excited state can cross the intersection assigned by thermal energy and can reach the ground state non-radiatively. So in this case, we assume a non-radiative relaxation process, and so with some activation energy. And here, as an example, I would like to show you DF emission spectra of cerium and cerium, in this case, lutetium aluminum ganide with praseodymium, and also I show you temperature dependencies for lifetimes of praseodymium and cerium in lutetium and aluminum ganide. And you can see that in case of cerium, dependencies are quite similar. So for yttrium ganide and lutetium ganide, but for praseodymium they're quite different. And the question is why? Why are they so different? And it's well explained. It's well explained by the coordinate diagrams. So the diagram for cerium on the left and praseodymium on the right perfectly explain it. So black curves on both diagrams represent 4F states, and green and red curves demonstrate 5D excited states of praseodymium and cerium in lutetium and yttrium ganates. So as you can see, stochastic shift is somewhat smaller in case of lutetium aluminum ganide. That results in higher thermal quenching for cerium and praseodymium emission in this host. And at the same time, potential barrier for cerium ion is much higher than that for praseodymium. That is due to different number of 4F states, which play a role in for energy drain for excited states. So, and another important non-radiative de-excitation process that competes with radiative de-excitation is connected with multi-phonon emission. So this type of process is often observed in the relaxation between 4F excited levels of lanthanides where there is no crossing between potential curves. So the transition probability is dependent on the energy gap, and usually multi-phonon relaxation is efficient when number of phonons exceeds 5 or doesn't exceed 5 or 6. So this is actually an unwanted process, and it makes energy transfer and less efficient, and it's usually most effective in compounds with lower energy of optical phonons, for example, in fluorides. And another possibility for non-radiative quenching is connected with photoionization that may happen when excited state is located very close or inside of conduction band. And in this case, electron may be delocalized in conduction band, and lanthanide ion will get ionized. And following this, there are generally two possibilities: formation of impurity trapped exciton, which may further relax radiatively or non-radiatively, or trapping of electron on electron traps with following decay or return back to lanthanide. So, and in this case, we consider divalent ion. So autoionization of 5D electron to conduction band leaves the ion in trivalent state, which has about 20% smaller ionic radius. And the surrounding anions will relax towards the trivalent ions. And this will immediately reduce Madelung potential at the nearby metal sites, and this allows the localization of electrons on nearby metal ions. So, so the Coulomb interaction of electron and hole with ionized lanthanide ion will lead to formation of impurity trapped exciton, and radiative decay of this exciton may be observed as so-called anomalous emission. And impurity trapped exciton can also relax non-radiatively. And here is an example for observation of impurity trapped exciton. This is calcium fluoride doped with ytterbium 2+ ion. And upon excitation, when we excite above band gap, we observed normal self-trapped excitons, and when we excite directly to 5D state of ytterbium 3+ ion, we observe impurity trapped exciton, which is observed about 580 nanometers. This is observed only at low temperatures, and at room temperature, impurity trapped excitons are completely quenched, and due to non-radiative relaxation to ytterbium 3+ 5D states. So, and impurity trapped excitons are quite rarely observed in oxides, so they mostly observed in fluorides. But here is an example of observation for impurity trapped exciton in calcium niobate, where impurity trapped excitons produce, where impurity trapped excitons produce broad emission. And in principle, an increase in concentration of luminescence centers in material should be accompanied by increase of emitted light intensity. But such behavior only occurs up to some certain critical concentration of luminescence centers. So, and above this concentration, we observe another reason for quenching, that is called concentration quenching. So, and basically two mechanisms generally explain the concentration quenchings. So due to very efficient energy transfer, excitation energy can migrate about a large number of centers before being emitted. So during this migration, quenching, during this migration, excitation energy may be quenched on a defect. So, and concentration quenching can also be produced without actual migration of excitation energy. And this occurs when excitation energy is lost from emitting center via cross-relaxation mechanism. And this kind of relaxation mechanism occurs by resonant energy transfer between two identical closely situated centers due to particular visual structure. So, and here you can observe example of decay curves recorded for 0.1 and 3% residuum ions. So at high concentration, you observe quenching, which results in decreasing of lifetime of presidium emission. So, and to conclude, I will just briefly say that performance of phosphorus based on lanthanide doped luminescence materials can be generally predicted and controlled. And efficiency of host impurity energy transfer is determined by multiple factors. And most important ones are related to mobility of host electronic excitations and the location of lanthanide levels within the band gap. And existence of defect-related traps is often responsible for low efficiency of energy transfer in the host. But in some cases, defects may represent a single or sole channel for transferring energy from the host to impurity ion. And non-radiative relaxation process within and around lanthanide impurity ion are governed by thermal quenching, cationization, and multi-phonon decay, concentration quenching, and some other process. So, and let me thanks. Let me thanks organizers for this meeting, and personally Dr. Emil Nande for inviting me. I also thank my colleagues at Euro Federal University for collaborations and my international collaborators, including Mike Reed, Roger Rees from New Zealand, Andres Meiring, Matthijs de Jong from Netherlands, Marco Bettinelli, Fabio Piccinelli from Italy, Andrei Belsky and Christian Pedrini, Marie-France Joubert from University Lyon 1 from France, Chufeng Shi, Huan Yang from China, and my Indian collaborators, Pushpal Ghosh, Yarenka Hural, Ruhal Sharma, they are from Harisangpur University from incredible India. I was in India about 3 years ago and was impressed. With kaleidoscopic variety of and rich cultural heritage of the country. And I thank you all for your attention. Please be safe and healthy. The situation with COVID is quite worrying now in India. I hope you will be all okay and fine. Thank you for your attention.
Thank you very much, sir.
You distribute very good lecture. I am Amol Nande. After a long time, we are talking in person. Are you able to hear me?
Yes. Sorry, can you repeat your question?
Yeah. Thank you very much for your.
Okay.
Yeah. So I'm not asking any question. If there are any question, just let us know from audience. I would like to ask Konstantin one question. All these are up-converting phosphor, aren't they?
Sorry?
All these are up-conversion phosphors? Means they are able to convert in, the energy to up-conversion phosphor. So are they used in solar cells?
Sorry, I can hardly hear you. Can you repeat that, please?
Can this phosphor used for solar cell application?
Oh yes, we are currently performing another work, and we're trying to combine this phosphor, barium gadolinium fluoride with europium. We are trying to combine with commercial solar cell materials, and actually we are planning to test some kind of experimental device and to check conversion efficiency very soon. So I hope we'll make some publication about this in some future.
Thank you.
Any questions?
Thank you, sir. Thank you very much. Please accept our sincere appreciation for outstanding presentation you made. And thank you so much for sharing your times and the experience with us. Thank you. Thank you very much.
Thank you.
Thank you, sir. Thanks a lot. Thank you, sir. Thanks a lot.
So, dear all, again, we are having one dynamic personality with us, Dr. Preeti Gupta, postdoctoral research from Leibniz Institute of Solid State and Material Research, Dresden. Here, I'm going to deliver some things about her. Madam completed her BSc in 2005, MSc in 2007 from Nagpur University, India, Later on, in 2016, he completed his PhD in physical science from CSIR, National Chemical Laboratory, Pune, NCL, Pune. After her doctorate, uh, she worked as a, or even after her post graduation, she worked as an ad hoc teacher in the Department of Physics at 2007 to 2008, and gave lecture to the condensed matter physics to MSc students and then practicals of the same students. From 2009 to 2010, he worked as a project assistant at IISc Bangalore force microscopy lab that they develop a prototype for fabrication of nanophorus alumina with the aim of controlling friction and wear at the solid interface. During the period, I had been trained and had on experience, hands-on experience, difference characterization techniques such as the FESIM and EDAX. 2010 to 2012 project assistant, the colloidal nanostructure and the nanomaterial group, National Chemical Laboratory, Pune, 2010 to 2012. Here she designed an experiment to engineer the band gap with will result into the enhanced protocatalyst activity in sunlight by synthesizing the different particle size of bismuth ferrite and making the composite with the graphene oxide. After that, 2012 to 2016, she did PhD, colloidal nanostructure and the nanomaterial group, National Chemical Laboratory, Pune. The studying it, the magnetic, electrical, and the thermal property to address is the multiferroic and the magnetocalorific property. Postdoctorate research 2016 to 2018 from Soft Photonic Research Group, IISc, Indian Institute of Science, Education Research, Pune. Design the non-linear optical material leading to the enhanced broadband upconversion and involved in understanding the dynamic of NLO material by ultra-fast laser pulse to create the UC emission of need and to provide the new of nanophotonic application such as the optical waveguide. Postdoctoral research at the thin film magnetic system group, University of Cambridge, 2018 to 2019. Understand the domain, wall dynamic and the chiral exchange bias of SAF multi-layer of mock microscopy, MFM, and the micromagnetic stimulation. And postdoctoral research, that is the IFWIN Leibniz Institute of Solid State and the Material Research, Dresden, that is September 2009 to till date, had worked aimed at creating the novel magneto-electronic system that are flexible, printable, contactless, and the lies at the interface of the nanotechnology, electronics engineering, R2R, and the additives manufacturing. Along with that, having the so many experimental skills, functional ink formulation, then additives printing, experience in designing the bench top experiments using wet chemical synthesis, solid state synthesis, electrochemical plating, thin film deposition, that is the chemical vapor deposition, magnetron sputtering, and the thermal evaporation. Fabrication skill, one and a half year experience of experimental nanofabrication across clean room fabrication, facilitation, and the training in process like the photolithography, focus ion beam milling, thin film deposition, electrochemical etching, and the plating, making mark slides for optical studies, and the designing skills, that is the 3D numerical modeling using the commercial package like the COMSOL, data analysis using tools like the MATLAB, and the micromagnetic stimulating using the MinMax and AutoCAD. Experience in inkjet printing, then dispense all, place all, laser cutting, R2R sputtering, deposition, MPMS, exculsquid, physical property measuring system, so many X-ray extraction and the thermal techniques, so many expertise, madam having Raman spectroscopy, and the work experience with the uh, ellipsometry, then transmission electron microscopy, PE loop tracer, X-ray photoelectron spectroscopy, femtosecond spectroscopy, that the back focal plan spectroscopy, and having awards. So many awards, madam having awards. One of the Indian top 1% cited paper in physics by IOP over period 2015 to 17. SERB overseas postdoctoral fellowship in 2017 to 18 and 18 to 19, 2 years from the government of India. Later on, Institute of Postdoctoral Fellowship of IISCR Pune, IISCR Pune, India in Physical Science 2016 to 17. Senior Research Fellowship from Council of Scientific and Industrial ISCR, CSIR, Government of India in Physical Science 2012 to 15. Best poster presentation International Conference on Magnetic Material and Application, and the same in 2014 in National Science Day organized by the NCL Pune, and the Magma 2013 organized by the Department of Physics and IISc Guwahati. Madam having the so many publications. So here I welcome Madam and kindly here invite for her topic.
Thank you, sir. Thank you, Dr. Amol, for this kind introduction. I hope I'm able to, like, everybody can hear me. Can anybody say yes?
Yes, 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 madam. Yes.
Okay, fine. So thanks for the kind introduction. So here I'll be presenting basically my work which I have done in Cambridge. And because now I'm working in Dresden, but I cannot discuss any of the work here. So that's why I chose my work of domain wall dynamics, which I did it in University of Cambridge. And so maybe it will be helpful for the students, and it can also give insight to what people are working around, irrespective of, like, you know, different functionalities, different techniques people are using in order to understand, since this conference is basically about the materials and nanotechnology. So we all know that materials play an important role if you design any experiments. So for any application, the materials are the core of your system. So whether it can be catalytic material, whether it can be magnetic, whether it can be some other material, bio or something, but the materials plays an important role. So here I would like to start with my talk. Just a second, I'll start the slides. Okay, sure. I'll just share my screen. Okay. So in Cambridge, I worked upon domain wall quantity properties of 3D nanoprinted cobalt nanowires, basically on the flexible substrates. I also worked on the rigid substrates. We also know, like, nowadays everybody, like, Internet of Things is already moving towards exploring the things which are thin, which are flexible, which can be printable even, and we can be carrying those things, like, you know, in our pockets. We don't have to carry like bulky things. So a lot of research has been focused in order to explore the substrates, in order to explore the materials, in order to explore the new physics. So here I'll basically, in this talk, I'll explain, like, how the magnetic storage is evolving and what are the people who are doing in order to improve the storage capacity. Like previously, we were using 1 GB of pen drive used to cost us like 1,000 rupees, but now it's just like 200 or 300 rupees, because now the research has made it to that level that the cost has been decreased. So a lot of research has been put forth in order to reduce the cost, and that comes when we study these kind of fundamental physics in order to understand, and then later on we can implement it um, to the final product formation, like final fabrication. So as you can see in my title, I'm basically talking about like domain wall. So domain wall is like very common and very, like everybody might have heard when we were in like students, when we were in colleges, we always say that when we have a magnet, they both are separated by a domain wall. Although we never understood exactly, like, because we have never felt what happens uh, uh, at that junction, and how that is playing an important role for designing that magnet. So here I'll discuss that. And conduit properties is basically like a conduit means, when we say domain wall conduit, like, then whether we can use that domain wall in order to store that information, or whether we want to store the information, like whether we can read it, whether we can write it without getting affected by any of the external parameters, like sometimes the thermal heating and some other things are coming into the picture. And so we wanted to avoid that. So we want to study good material which can give us this good domain wall conduit properties. And since the magnetic storage, we all know that Moore's law, it always says that number of transistors, it keeps on doubling every year. So people are working in order to reduce the size of the transistors in order to assemble millions and millions of transistors in a small frame of work. And so there are a lot of work where people are doing in order to explore the materials. So they are trying 2D to going to 3D. And then they are also trying, because when we go to 2D to 3D, we also use like new physics comes into the picture, which nobody like have studied. So we also need new tools in order to understand that. And cobalt, since cobalt is like very basic, very fundamental, which is well known in the research field, and which is so that's why we have chosen here the cobalt nanowire. So let's talk about magnets and data storage. So whenever we hear the word magnet, we always feel that it gets attracted to something. So it's not the magnet which is getting attracted, it's the material. So when we have a pool of materials with different materials, and when only two of it get attracted, that means that is magnetic material. So that is having some property which is getting attracted irrespective of all the other materials which are present in that loop. So although the science of magnetism is like very complex, but we have always seen this in our day-to-day life. Everywhere we use this magnet. So one of the example we can see here is this man is trying to remove the metals from the junkyard by carrying the huge magnet. So this is like very day-to-day application where we use it. And the second and most important thing, I guess everybody must have done it during their school times, is like take a magnet and then rub the nails around it, and then try to attract with that nail any other magnetic material, because this nail acts as a temporary magnet. So that time we don't understand, like, okay, whether it is why it is doing such a weird thing. It so makes you interesting, but still you feel that, okay, maybe we don't know so exactly what is happening. So this is the very common thing we have been using it, but we have not been understood in that, in a layman people and layman language, we don't understand anything. But since nowadays everybody is like using smartphones and using hard disks, pen drives, so we keep on thinking, like, for an example, for this hard disk, we always see like how is it possible to store this much of information in this such a small disk? What exactly is happening here, and how are we storing it? So the best example is like I can give is, yeah, the how to store the information with magnetism. So best example is like, let's understand, like, we have this nail, and if we want to suppose I am telling to my friend, let's meet at some place, and if we want to decide by using a magnet and a nail, how are we going to decide it? So we take a magnet and then we take a nail, and I will just rub it around and then leave it in an envelope around the friend's house. And then when he comes and sees, and he just took the nail and he goes and tries to take a paper clip. And if it gets attracted, that means yes. That means yes. That means one. So that means that I have stored the information in such a way that he understands it, and he understands that, okay, I'm gonna meet that person, I'm gonna meet her at this point of the time. So it's a pretty way to, just leave a message for someone like us, like we humans generally communicate. But when we want to communicate digitally, then it is important to illustrate something and tell that, okay, this is the way we are storing the information. So the important thing I want to tell here is, like, after this much explanation, like, this magnetism can be used to store information. So, like, the basic example, as you can see, that nails, when there is no magnet, the domains are arranged randomly. But when we put a magnet close to it, the domains get arranged in a precise fashion in direction of the field the magnet is producing. And this is how the domains look like. I mean, I never saw this during my school time, but although, yeah, in masters we have seen this. So seeing these are the different domains, and these different domains can be act as a bit, and they can be stored as an information. So, like, so just imagine, like, if your computer has a 20 GB hard drive. I mean, now people are using a big one, but just imagine like that. So if your computer is having 20 GB capacity, or a MP3 player or iPod or any other electronic, so it's like this small box is containing like 160 to 200,000 million small iron nails, and each of it is acting like a small bit, and that bit we call it as an information. So either it is 0 or it is 1. So if it is magnetized, then we say 0. If it is not magnetized, then if it is magnetized, we say 1. And if it is not, then we say 0. So this is how the information is stored in most of the devices, whether it is a CD, whether it's a phone, whether it's a flash drive, any of it. But the main point here is, like, why are we interested in? So why are we, as I said earlier, we are trying to move from 2D to 3D. So why are we interested to move from 2D to 3D materials? So the most classic example for 2D technologies is the track media, where they have a millions of these transistors, which is lying along the two-dimensionally. And so the small one, which you can see, is the MTG memory element, and these each transistors are arranged parallelly with a certain distance, and that is stored as an 0 and 1, and but it depends upon the current which is flowing through it. If it is getting magnetized, then it is 1, and if it is not, then it is 0. So that's how the information is stored in 2D technologies. I mean, in any of the technology. But the main point here is why we are moving from 2D to 3D is that, as you can see, when you try to, I will just show. So, okay, the green column, which is showing, like, this is how the 2D things are arranged. Suppose we are arranging only 7 transistors two-dimensionally. So what will happen if you move to 3D? It will be more than 14 transistors. So in this way, we are trying to increase the capacity of the storage. So, like, if we are now, I'm using 1 GB of flash drive. If I can arrange like this, then I may be increasing my storage capacity to 2 GB or more than that also. So it's like almost doubling up the storage by introducing and moving from 2D to 3D technology. So the 3D technology is like not very new. It's been a long time, like in 2015, Stuart Barking has come up with this fantastic idea of involving domain wall dynamics. So, like, making a racetrack which is like perpendicular, which is like vertical. It's not like flat. So in the same way, he's increasing the capacity and storage and even the speed with which the memory is functioning. So that will also increase our speed of our computers and rest of the electronic gadgets which we use. So, but the problem is, what happens when we switch from to 3D. It's not like very simple that you can just take a 2D material and try to make it 3D, because when we move to 2D to 3D, this is what happens. Like it can be nanowire, it can be nanotube, it can be a vertical soliton conduit where the alternating magnetic layers are there. It can be like a nanomembrane, which is like folded, and nanohelix. But the main problem is when we move to 2D to 3D, we also need we already don't know like what will happen, how the material will behave. So new physics will come out of it. Although new application will definitely be there, but then we also need to, in order to study the new physics, we also need new characterization and new computational tools in order to address whatever interesting results we are getting. So then in context two, since we are talking about the magnetic storage, we can also see here like how the spins are different, how the spins is behaving differently when it moves to 2D to 3D. So we also need a tools where we can understand how the spin dynamics is there when it moves to 2D to 3-dimensional geometry. So that's why we need a new tool, and we also need new like simulations in order to understand whatever we are getting experimentally. And one of these tool is this focused electron beam induced deposition. So where I was working, University of Cambridge, those were the pioneer in this field. Like they have introduced this FEBIT concept, and they are commonly using this technique in order to make 3D structures. So what is it exactly? I mean, sorry about this. There is some problem with the image, but I can explain it. Like we have a substrate. It acts like it's similar to the fib, or like I can say it is more similar to the chemical vapor deposition, where we dissociate these molecules, whatever we want to deposit on a substrate, by thermally. And the external energy which we are giving is thermal. But here we are using the electron beam. So since we know it is very focused, so we can dissociate. So we have this gas injection system where we try to introduce the gases. And what are the gases which we are using? Suppose we are depositing cobalt. So we are using cobalt precursor gases. And not all gases can give you good purity. So we have to try different gases in order to give a good amount of atomic purity for the material. So, and also we also need a lower dissociation energy so that it doesn't require much energy to dissociate the molecules. So when we inject the gas from this gas injection system and the electron beam is focused, it gets dissociated and sits on the substrate. And there are the volatile fragments, it gets removed, like it just vaporizes. And when we scan the beam, so here, how do we write the structures? So it's like a pen. So we have an ink that is like a beam, and then we have this ink which is having these materials, like these molecules, and we are scanning it. So when we scan, we tell the beam how to scan it. So we just inform the beam, this is your design, this is how you need to scan it. So the beam scans, and then it makes the molecules to sit in the same fashion it is scanning. And that's how we get a 3D structures out of a very innovative but yet simple, and everybody knows, like SEM and TM we knows, and then we also know the fib. There also we do gallium irradiation and all. So this all concept has been used to combine these tools and then make it something like this, like focused fabric technique, where we just use this ion beam, electron beam to irradiate and write it. So it's like a direct pen lithography. You just, this act like a pen. You just tell what you need to fill. It's like you need to tell it like this is your design, and this guy will write it. So after seeing this, you can already imagine like this is very promising technique for the emerging field of 3D nanomagnetism, because when we are growing 3D structures, we also like, this is because we also grow nanowires on something with our chemical roots, but the purity and the crystallinity is the important factor when we talk about the devices. And this is one of the best tool where we can directly use it as a pen in order to write it. I can just say like a pen. So in our group, we have already used different, like we use a CAD. That's a software. We use it to design the coordinates, and then we tell this Fabit that this is your coordinates. This has been fed to the electron beam, and the electron beam writes it by scanning these coordinates. So this is how the 3D structure looks like. And then the left side, you can see the coordinates, which is like Fabit CAD design, which we used it in order to get these kind of structures. So this is now like in a preliminary stage, like we are now designing the structures, whether we can do it 3D using this. So first it's like we have to see whether we can do it or not. And then we have to also see whether we are getting the atomic purity to that level so that we can use the physics behind it to design our new system. This is one of the examples. Like you can also design a tip to like AFM tip also, you can design it, and then you can design some octahedrons and some icosahedron, different segmented nano objects. Although like it is very complex, but Fabit gives you flexibility to pattern these complex multi-segmented nanostructures, and these are all nanostructures. So this can be made using the Fabit. So as you can see, like Fabit is like most versatile tool, which we have used it in order to get these kind of structures out of it. But the next question is, can it be combined with a flexible substrate? Because you're using electron beam, and we all know like with the energy, the thermal heating is also too much. It can also damage the substrate. So we also need to be very careful about what substrates we are using it. And one of the important flexible substrates, it is flexible, it is thermally good, and Captain. So Captain is polyamide film, which is like heat resistance. You can heat till 230 degrees Celsius. We can use that substrate. And we also have some polymers which are like heat resistance. They go at least to certain temperature, like 120, 180. Like PET, it can go till 200. Safety, I mean, it is said that at 280 it can be used, but safely you can go till 200. And so it will be very interesting. So we thought that maybe instead of doing on silicon all these structures, if we can, it will be very interesting to explore if these kind of structures can grow on flexible substrates, because we know that the surface roughness plays a very important role in whatever material we are growing, whether it's a thin film or whether it's a 3D structures or any 2D structures also. So that was a challenging thing to do, because we were not sure whether we will be able to grow that kind of quality structures. Like when we grew this in silicon, it was giving at 90 to 95% atomic purity. But this was the first time we did it. And to our surprise, we got a good result, which I'll show later. So let me tell you where it has been grown. So it has been grown in these structures in Kelvin Nano Characterization Center of University of Glasgow. And this is how the instrument look like. And I mean, similar, typical like SEM, but it is having some attachments where we can inject the gases, we can pull it down, we can scan it, and we can feed it some electronics so that we can feed those CAD designs. And this is how the inside it is look like. Similar to the SEM, we have a stuff. We have different nozzles where it determines the gas injection, and then beam scanning also. And this is the like experimental things. So we were like successfully fabricate cobalt structures, and with the purity of 95%. And if somebody interested, we have used like 5 kilovolts and 1.4 nanoamperes. And but we grow here like L-shaped nanowires and some squares on rectangles on the captain. So like cobalts are basically, so like for L-shaped nanowire, I'll like, why are we interested in this L-shaped nanowires? Because we want to use the domain wall in order to read and write information. So when using this L shape, the domain wall gets pinned at the corner of the L shape. So this U, as you can see, it just pinned there when we apply a magnetic field. So we have like purposefully used this, and the arrow at the end ensures that the domain wall doesn't propagate and no new like nucleation of domain walls is not happening. So that's why this design has been decided in order to make the cobalt nanostructures out of Febid. So this is some details which I don't want to go into it. So as you can see, we have like successfully grown these L-shaped cobalt nanowires. Like these are different lengths and dimensions. We have used it in order to have, because only one, if we grow only one, we are not sure what purity we are getting it. So we try to grow in one substrate, like maybe 10 or 20 of these, and then try to measure and characterize later on to see which one is giving a good atomic purity, and then we can see what parameters we have decided in order to grow this, and then later on we can, because this is just the starting phase of it where we are trying to understand and like how we can do it. So these parameters are equally important. So we also try to grow some wires which is like not L shaped, it's like normal wires, and we also try to grow, as you can see in M, we also grow some squares, and let's see what happens then. So now we have already grown it. So now we need to see how the topography, since it's a magnetic material, we also need to see how the magnetic behavior is. So the very quick measurement which we can do is the MFM. So topography looks good. It gives almost the same dimension what we have used it to create those wires. And but when we check the MFM phase, the alternating dark and bright spot in those ends of the L-shaped nanowires, you can see, tells us that the direction of the the direction of the spins is like the up and down, like it's opposite. And that's what I said, like as I said, yeah, this is how the direction is. They both are opposite. So in order to get that MFM images like this, we also need to magnetize the tip of the sample. And then we also need to magnetize the sample in such a way that the domain will be at the center, the yellow marked region. Although we were not able to see here, like the resolution is not very good, but we can say that it's a single domain because of the alternating like bright and dark and white spot. And if you want to confirm it, so we also confirmed it, whether it is the true, because MFM gives us a lot of artifacts. And so you can just magnetize the tip in the other way around. Like if you have magnetized at the north side, you magnetize around the south. And then you can see that the contrast also changes. The black becomes white and the white becomes black. So that means this is the true image. This is not an artifact, which we can generally assume it from MFM. So the pretty same like for silicon, for Kapton, we got the same tomography, same amplitude, same phase, and the same contrast, and the dimension were also same. So, and from there we can also calculate the uniform thickness, like AFM gives us the thickness of the wire, and it was pretty okay, like 80 nanometer thickness, and the width was 300 nanometers. And the length is around 12 microns. So as I said earlier, why we want to study the domain wall conduit. So this is how it is. Like if let's understand, like if we are using a planar wire and it is connected to rest of the circuit as it is written here. So if we make it align in certain direction, if you magnetize in certain way that the domain wall gets at the middle, and then if we apply a field, so for a good conduit behavior, we need a propagation field less than the nucleation field. So what is propagation and nucleation? Nucleation is basically the field which we are applying in order to nucleate those domain walls, in order to align it. And propagation is the field where we wanted less field, because then we can use very small field to move those domain walls. So the good conduit behavior tells us that you should have a propagation field less than the nucleation field. Otherwise, your information is lost, whatever you are storing it. So that's why we don't want the undesired domain walls in order to have a good conduit behavior. So this is what it happens in L-shaped nanowires. We intentionally created this L shape. We wanted it to be pinned at the corner of the L-shaped nanowires, and depending upon the field we are applying, either it is moving, but it is not getting lost. Information is preserved. Why? Because here, when we studied the magnetic information from it, it tells us, like when we did the MOC microscopy, it tells us the nucleation field is more than the propagation field. So that is what we want, and we want a good difference out of it. So the next slide will tell you. So when we use the silicon, we got the blue one tells you the nucleation field, where the amount of field which is needed to in order to create that domain walls. So that's around 300 Ørsted, and the propagation field was much less, around like 60 or 70 Ørsted. And the red part which you are seeing is a sequence which we write it, like how to apply a field, how to in which direction, so that it will nucleate, because this is a complex structure of L. This is not like a very planar structure. So when we did in the Captain also, successfully, we have observed a good nucleation field around 140 Ørsted, and the propagation field was almost half, like 60 Ørsted. So we were like successful in doing what we wanted to do. So we wanted to have a material in order to have a good domain wall conduit behavior. And this is what it is showing, both on silicon, both on Captain, so that the technology can be shifted from a hard rigid substrate to the flexible substrate, and later on for the IoT applications. But the next, so now since we have been successful in exploring the material, we also wanted to understand like how the strain will affect on these structures, because there is one more important thing when we talk about the storage. Like we wanted to know, like if we are reading electrically, and if you are reading magnetically, like if you're reading magnetically, then we are taking like lot of energy. So we want to use less energy. So that's why we are trying to explore different arena in order to understand how we can do it. So one of the important thing which we can use is the strain. So suppose if you are applying a strain to a system, and it is enough strain is there to displace that domain wall. So that solves our problem, because it's like it consumes very less energy, and we here use like very small like actuators in order to get that, and the flexible actuators can be built easily if you want to merge it to the flexible substrates. But here I have used like this is a commercially available actuators. So the black part is the carbon pad, and then we put the actuator on it, and then we put the sample, which is connected, and this is the actuator is connected with the connections given like this. This is a real-time image which I took it in order to study. So definitely, if we want to apply a strain, we cannot use silicon, because the actuators will not be able to transfer that much amount of energy so that it can absorb any significant change. So that's the reason also we wanted to study on the Captain. And this setup like provided around 150 Ørsted of anisotropy field for the cofeptin films. So we thought that, okay, now we can also try with the cobalt and see how it is affecting it, whether we are able to transfer that strain in order to switch the domain walls or not, or whether any shift we can observe. So what did we observe here? So we did some experiments on it, and we tried for rectangular and L-shaped wires both. Although for L-shaped wires, we observed very little difference, like very small change, around say 10 to 12 Ørsted of difference was observed when we applied the strain from 0 to 150 volt. Similarly, we also did not observe like very good, interesting results for normal wires, normal thickness. But when we talk about the squares, we have seen that we got significant change in the bias field. So the coercive field has changed. So that means we can use this strain in order to change the coercive field of these squares, which are like Fabit created squares out of it. But the problem was, why did we not observe in the nucleation? Like why did we observe very less, which is what we don't wanted it. So that's why we needed to do so the results were like very complex. We were not able to understand it, and it was very difficult to conclude. So we thought, let's do some micromagnetic simulation to understand what exactly is happening with these cobalt structures. So then we did some micromagnetic simulation, and these I'm presenting the remanent magnetization states. So when we applied the anisotropy, like we are having like normal squares. This is not like an L-shaped nanowire. This is like a normal wire of certain dimension. I'm using it. And when we applied this anisotropy field along the wire axis, so we did not observe any change in the domain wall patterns. So it is basically acting like a transverse domain walls. There is no new pattern is formed, no breaking of domains, and no complex structures are observed, even though when we applied this anisotropy field this much large, like 4.5 into 4 joule per meter cube. But then what happened when we applied the strain? But this is what we should understand, that when we are applying the strain along the wire axis, we should not observe it, because the shape anisotropy plays an important role. So because when it is along the wire, the shape anisotropy is already too much and it is not able to overcome that. So when we apply theta equal to 90, like perpendicular to the axis of the wire, then we observe there is a change. There is a small change. This transverse waves, this like transverse domain wall got shifted into multi-domain, like multi-transverse domain walls when we increase to ky around 4.5 into 4. But why do we still, the change is like not too much, and how much change we observe? So, but this is the schematic, like how we are using it. Yeah, so the Walker field was like 10 oersted to 12 oersted. Like this is the field where the domain walls is behaving differently. But the reason we could not understood is like why. Still, so what I can understand from here is that we have already seen experimentally, we have already seen like by simulation also, but we were not able to find the reason why. So like experimental and theory proves the same. But then we did some back calculation and we got to know like the shape anisotropy for our cobalt structures is 10 into 10 raised to power 6. And the uniaxial anisotropy, which we are applying, is 4.5 into 10 to the power 4. That is the maximum which we applied there. So here, as you can see, the shape anisotropy is ruling on it, the anisotropy, the magnetic crystalline anisotropy, which we are giving it to it. So that's the reason we did not observe any change, or very like significant change we did not observe, only like very few oersted change, which we cannot say like it's a true change. So that's how we concluded, like, cobalt is having a good shape anisotropy field, and that's the reason we could not observe a bigger change so that we can use it. So that's the reason we decided that we should shift from cobalt to Fe, because Fe is having good anisotropy and probably we can observe some change there. But although that was not my work, but then that was the conclusion of it. So with this thing, I have pretty some already concluded it, but I can just conclude in this slide. Like, as you can see, that Fabid is like very promising technique if you want to create any 3D nano structures out of it, and it also open up to like a new way for 3D nanomagnetism. And in this work, we also got seen that it is possible to grow these cobalt nanostructures even on the flexible Kapton substrates with 95% atomic purity. And it grow well, and it is similar to the silicon. So silicon is why we always compare with silicon, because silicon is already in the industry. So if you want to compare anything, we have to first do it on silicon, and then we have to switch it to some other substrates in order to understand whether whatever we are thinking and whatever we are doing is doable or not, whether it should come at that level of quality. So we have observed already that silicon and Kapton both gave us the good conduit behavior on the cobalt structures. And although the strain does not affect the lower aspect ratio wires as expected, and as we have also seen in the simulation, but for wider wires, we have seen that the strain is enough to change its magnetic properties. So from here, we also concluded that maybe wider wires are needed, but we also need to see how wide we can go, because we are talking about nano dimension. We want to make it crisp at one particular pace, make it more confined. So we want to reduce the size instead of increasing it. So maybe it is best to see and find some other new materials where we can use our strain anisotropy to change the magnetic properties of a material, and then we can see whether we can able to store that information in a way we want. Like, we don't want the information to be lost. and we don't want much energy to be put into it to create those domain walls and the storing capacity. So these are the like few parameters which goes hand in hand, and we need to decide which one we need to compromise it and which one we have to go ahead. So with this work, we decided that, okay, we can also grow some square structures, and or else we can go with some other magnetic structures like iron. And so this was the main context of this work. But although cobalt gave the good domain conduit properties, because cobalt is known to be very good magnetic material, and we observed the similar with the simulation as well. And this is where I worked in Cavendish Laboratory, and Amalio was my mentor, and Alexander was working with me. He was assisting me for some of the work, and this is where I work now. This is IFW Leibniz, and this is a group photo. And I would like to thank you, the organizer and organizing committee as well, to inviting me for the talk and allowing me to present my crazy and interesting work, I believe. And thank you so much. Any questions? I'm welcome.
Thank you, madam. Thanks a lot.
So anybody having any questions, kindly ask. So thank you, madam, for your nice presentation and nice information.
Thank you so much.
So on the behalf of International Virtual Conference on Material and the Nanotechnology 2021, actually I take this opportunity to propose a vote of thanks to those who have directly and indirectly contributed to this session. And at the outset, I thanks our today's all resource person. We are really enlightened with your knowledge and the presence. Our heartfelt thank to our participants for the more active participation. With these warm words and the kind message, we are going to end our today's session. Thank you. Now I hand over mic to Dr. Amol Nande, sir.
Thank you, sir. I would like personally to thank Konstantin, Priti Gupta ma'am, Konstantin sir, and Shinde sir, Haranathan sir, and Ranganathan sir for their outstanding invited talks and knowledges they shared with us for today. And we will take for 15 minutes break, and we will resume oral presentation session at sharp 3 o'clock. There will be two parallel sessions. One will be on the same link, and the other one will be on Google Meet, which I shared already with the participants as well as in group. And during this break time, we will flashing all the posters which we reviewed for poster presentation competition, and it will be marked for today. So far, thank you very much for your vision and be with us for such a long session. Thanks a lot. Have a nice time. Thank you.
Thank you, sir.
The link going to be the on for all the time. So especially for dignities, if they want to take a leave, they can. Thank you for their cooperation and patience to be with us. Thank you.
Amol sir, I want to make an announcement. Can I?
Yes, sir. Yes, sir. You can.
It is announcement for session 6, which is the last session of our conference, and near about 16 to 17 participants are there. So I request all these participants to be present there, because as all of we know that you are running 1 hour late. So I will play the PPT or presentation of those who are online present there. Okay, be there and cooperate us. Thank you. Thanks a lot.
is to develop a cost-effective system which can give a voice using a smart globe. Communication will not be barrier between the two different communities. With the help of this globe, disabled person can also get a chance to grow in their life of respective career. Good morning. I am Amruta Rithe from PR Pote Patil College of Engineering and Management, Amravati. My project name is Smart Hand Gloves. So, communication is the only medium by which we can share our thoughts or convey the message. But for a person with a disability like deaf and dumb, there is many difficulties in communication with normal people. So, the main aim of this proposed project is to develop a cost-effective system which can give a voice to voiceless person with the help of smart clothes, and this system will help them in improving their qualities of life significantly. It means that using a smart globe, communication will not be barrier between the two different communities. With the help of this globe, disabled person can also get a chance to grow in their life of respective career.
Good morning, everyone. I am These raw materials were chosen as precursors in the preparation of activated carbons because of their availability and their Good morning, everyone. I am Riman Dahri, Tunisian chemical engineer and PhD student from the Faculty of Sciences of CAFSA. I'm here to present my work, Comparative Adsorption of Congo red dye onto activated carbon prepared from prickly pear seed cake and olive wood. I would like to thank the organizer and all the sponsors to provide me this opportunity to present my work. So, starting with a short introduction, with the development of the industry, environmental contamination has become increasingly alarming. Thus, the problem is further aggravated when it comes to toxic pollutants, such as organic dyes, in particular, anionic dye Congo red. A number of treatment technologies have been adopted for the removal of dyes from wastewater. Among these processes, adsorption is one of the most favorable and economical methods, and activated carbon is mostly used for treating wastewater due to its important porous structure its high surface area, and high absorption capacity. Motivated by the search for a new precursor, olive waste wood and perfectly pure seed cake, biomass after bio-oil extraction, have been considered in this study. These raw materials were chosen as precursors in the preparation of activated carbons because of their availability and their physico-chemical characteristics. The main purpose of the present study was to evaluate the feasibility of developing activated carbon with large porosity from these raw materials, and phosphoric acid activation was applied to produce these adsorbents. For the preparation of activated carbon, first the raw material was carbonized, then activated using phosphoric acid. The residual phosphoric acid was eliminated from activated carbons by washing with hot distillator water. Batch absorption experiments were carried out to evaluate the effect of process parameters, pH of solution, adsorbent dose, contact time, and initial dye concentration. For the characterization of activated carbons, observation under a scanning electron microscope shows that the obtained carbons have a highly porous structure. Also, Boehm titration was used for the activated carbons to quantify acidic functional groups. It can be seen that the obtained activated carbon surface have mainly basic groups and a lower number of acidic groups. For Congo red adsorption study, the results indicated that the obtained activated carbons are efficient adsorbent for anionic dye in acidic conditions. For the effect of adsorbent dose, there was an increase in adsorption capacity whenever there was an increase in adsorbent dose. The equilibrium adsorption data for the anionic dye activated carbons system were analyzed. The fitness of Langmuir model to the adsorption process points that Congo red was adsorbent on specific monolayer onto both activated carbons. For the effect of time, the adsorption on both adsorbents increased as the contact time was varied before becoming constant after 214 minutes. Finally, as conclusion, this study revealed that activated carbons synthesized from olive waste wood and perfectly pure seed cake are suitable for Congo red removal from wastewater. The obtained results show clearly that the use of these raw materials has important advantages, not only in terms of agricultural waste valorization, but also in regard to decreasing dyes concentration from wastewater. Thank you for your time and for your attention.
Thank you.
Hello everyone, my name is Avinash and here I'm presenting the poster on the solar cell where the CDS and AGTS core shell has been prepared by the simple CBD method and katana exchange method, where CDS and AGTS has been confirmed by the XID analysis. All the peaks of the CDS and AGTS are well matched in lattice in HRTM analysis. The surface morphology of the CDS nanomers and core shell of AGTS has been confirmed by the same analysis and HRTM analysis. The peaks of AG, CD, and S are confirmed by the XPS analysis. The photoelectrochemical solar cell of this prepared thin film is showing the 0.29% of efficiency for the this prepared photoanode of CDS and AGTS core shell.
Bismuth vanadate deposited on stainless steel substrate by using Silar method. For that, bismuth nitrate, sodium metavanadate, glacial acetic acid were used for the deposition of bismuth vanadate. 40 Silar cycles were performed as a optimization number of cycles. After that, different characterizations were done. First of all, X-ray diffraction analysis. From that, we got confirmation of deposition of bismuth vanadate. After that, FTIR to get functional group analysis. After that, SEM and EDAX analysis. From SEM, we got sponge-like structural morphology, and from elemental mapping, we got uniform distribution of the elements throughout the film. From CV, we got 707 farad per gram at 3 millivolt per second. From CD, we got 199 farad per gram at 3 ampere per gram. From impedance analysis, we got 5.723 series resistance. From stability study, we got 112% capacitive retention, which supports good use of this material for supercapacitor application.
We have grown CAC thin film observer layer by using the two-stage process. In the first step, the precursor layers containing the stacked sequence of indium, copper, silver, and selenium were deposited in high vacuum by using an electron beam evaporation method. In the second step, the post-channelization of the precursor stack was carried out using the horizontal tubular furnace. The XRD results indicate that the film channelized at temperature from greater than or equal to 450 degrees are found to be in CAC single phase. The Raman results further confirms the formation of the CAC single phase. The EDS analysis indicates that the film channelized at 475 degrees are nearly stoichiometric. And the FESM images indicate the compact grains with the average size of 1 micrometer. The optical properties reveal that the film channelized at greater than or equal to 470 are found to have CAC single phase, which corresponds to the band gap from the 1.13 electron to 1.05 electron volt. The electrical properties reveals that the film channelized at 475 degrees had the higher mobility with the carrier concentration in the order of 10 power 16 centimeter cube. The overall results indicate that the CAC 475 degrees temperature was found to be an optimum temperature to grow the high quality CAC thin film observer layers.
Good afternoon all. I am Godkejs from PDVP College, Tasgaon, Sangli. Today I am going to present my research work as temperature variation of permeability for SM device substituted magnesium ferrite. Magnesium ferrite is important ferrimagnetic material Magnesium and magnesium substituted ferrite have a number of applications, such as it is used in electronic devices, magnetic recording devices, high frequency devices, etc. SM device substitute magnesium ferrite having composition Mg SM.4 Dy.6 Fe2 minus XO4 were synthesized by chemical combustion route. Variation of permeability and loss factor were obtained by measuring LS and Q factor values by using instrument Hayuki LCR-Q meter. Table 1 represent data on Curie temperature and corresponding values of permeability and loss factor. Figure 1 to 4 shows a temperature variation of permeability and loss factor. From figure, it is seen that permeability of SM device substituted magnesium ferrite vary with temperature from room temperature to Curie temperature. The value of Curie temperature of prepared samples lies between 295 to 325 degrees centigrade. From thermal variation of loss factor, it is seen that ferrite must be used below Curie temperature for low loss factor. Thank you.
Hello everyone, I am Sujay Anindra Boble from Pote College of Engineering and Management, Amravati. I am doing my specialization in electrical. The paper that I work is a part of my final year project, along with my teammates, and have taken it as our research interest, which is about the smart agriculture system. We believe that agriculture contributes majorly in the growth of nation. So so we have presented the study of automated system which can solve many problems regarding agriculture like water scarcity, insufficient power supply, and so on. Paper is about increasing agriculture efficiency with productivity using small quantity of water as well as protecting plants from fungi. There are various problems related to agriculture which results into declination in productivity of agriculture. The project referred to smart agriculture as it usage of technology like IoT, artificial intelligence, and sensors in the farm. The ultimate goal, the ultimate goal is to increase the quality and quantity of crops while optimizing the human labor used. The technologies used in smart agriculture are irrigation control based precise plant nutrition and climate change. Thus, there is high precision and 24 by 7 control eventually, leading to considerable savings in all key resources used like water, energy, fertilizers, and time, and thus lead to increase in crop yield while reducing the cost of fertilization and chemical treatment as well as human error. The problem like scarcity of water, insufficient power supply, which affect the productivity of food, can be solved using automated irrigation system using solar power. Various factors like humidity, moisture, temperature can affect the plant and thus affect the productivity. By using various sensors which can measure the respective parameters and with the help of then we can make the circumstances favorable for plants. All these features make the automated agriculture system sustainable so as to improve efficiency. The goal of study is to discover the technique for irrigation system automatically controlled using software in such a way that allows the farmer to monitor all the information and manage the device through their smartphone. Thank you. Stay safe.
Good morning, everyone. I am Rimen Dahri, Tunisian chemical engineer and PhD student from the Faculty of Sciences of GEFSA. I'm here to present my work, Comparative Adsorption of Congo red dye onto activated carbon prepared from prickly pear seed cake and olive wood. I would like to thank the organizer and all the sponsors to provide me this opportunity to present my work. So, starting with a short introduction, with the development of the industry, environmental contamination has become increasingly alarming. Thus, the problem is further aggravated when it comes to toxic pollutants such as organic dyes, in particular anionic dye Congo red. A number of treatment technologies have been adopted for the removal of dyes from wastewater. Among these processes, adsorption is one of the most favorable and economical methods, and activated carbon is mostly used for treating wastewater due to its important porous structure, its high surface area, and high adsorption capacity. Motivated by the search for a new precursor, olive waste wood and prickly pear seed cake, biomass after bio-oil extraction, have been considered in this study. These raw materials were chosen as precursors in the preparation of activated carbons because of their availability and their physico-chemical characteristics. The main purpose of the present study was to evaluate the feasibility of developing activated carbon with large porosity from these raw materials, and phosphoric acid activation was applied to produce these adsorbents. For the preparation of activated carbon, first the raw material was carbonized, then activated using phosphoric acid. The residual phosphoric acid was eliminated from activated carbons by washing with hot distillator water. Batch adsorption experiments were carried out to evaluate the effect of process parameters, pH of solution, adsorbent dose, contact time, and initial dye concentration. For the characterization of activated carbons, observation under a scanning electron microscope shows that the obtained carbons have a highly porous structure. Also, Boehm titration was used for the activated carbons to quantify acidic functional groups. It can be seen that the obtained activated carbon surface have mainly basic groups and a lower number of acidic groups. For Congo red adsorption study, the results indicated that the obtained activated carbons are efficient adsorbent for anionic dye in acidic conditions. For the effect of adsorbent dose, there was an increase in adsorption capacity whenever there was an increase in adsorbent dose. The equilibrium adsorption data for the anionic dye activated carbons system were analyzed. The fitness of Langmuir model to the adsorption process points that Congo red was adsorbent on specific monolayer onto both activated carbons. For the effect of time, the adsorption on both adsorbents increased as the contact time was varied before becoming constant after 214 minutes. Finally, as conclusion, this study revealed that activated carbons synthesized from olive waste wood and prickly pear seed cake are suitable for concrete removal from wastewater. The obtained results show clearly that the use of these raw materials has important advantages, not only in terms of agricultural waste valorization, but also in regard to decreasing dyes concentration from wastewater. Thank you for your time and for your attention.
निळे सर नमस्कार.
Good afternoon.
गुड आफ्टरनून. छान वाटलं तुम्ही जॉईन केल्याबद्दल.
Good afternoon, sir.
गुड आफ्टरनून. अरे उगे मुगे गुड आफ्टरनून.
हॅलो, काय म्हणता सर? कसे आहात सर?
मस्त मजेत मजेत एकदम. चालू करा लवकर.
सर छान कॉन्फरन्स ऑर्गनाइज केली.
हा?
छान कॉन्फरन्स ऑर्गनाइज केली एकदम छान.
आमचा पॅटर्न आवडला का म्हटलं तुला?
सर खूपच छान सर, खूपच मस्त
अच्छा अच्छा.
केली एकदम. फारच
बरं
छान
झालं
सर.
सर. तुम्हाला लोकांचं कॉपरेशन मिळालं त्या निमित्ताने.
छान सर छान. म्हणजे अमोल तसंही फार ऍक्टिव्ह आहे सर.
हा नाही चांगला आहे.
अमोलचा काही प्रश्नच नाही आहे. त्यामुळे
चल
फार
चालू करा, उशीर होत आहे.
हा सर.
चालू करा चालू
सर
करा.
सुरू करूया.
हा.
हा सर. हा सर. सर एक सेकंड. Good afternoon, one and all. Uge sir, good afternoon.
Good afternoon, sir. Good afternoon, and happy to see you.
Sir, same here, sir. How are you, sir?
Fine,
how are you?
fine now. I'm fine, sir.
Okay, sir. If you don't any objection, we can start our session, sir.
Organized conference, sir. Really great. Congratulations. Yeah.
Thank you, sir.
Go
Thanks
ahead,
a lot,
go
sir.
ahead.
Okay, sir. Okay. Good afternoon, one and all. Let us introduce our chairperson of. Friends, we have a very genuine personality, a very talented personality, Dr. Nilesh Ugemuge.
And he is now having near about 3 net cleared subjects in his bag, and he got 2 doctorate degree in 2 subjects. He's a doctorate in physics plus a doctorate in the management. And friends, most importantly, is very credible, and really appreciate the sir. He has nothing but 45 more than books in his bag. 45 books, sir ne likha hai. It's very, very good. It's very nice, sir. I really appreciate your effort. And sir currently working as an assistant professor in the physics department, Anand Niketan Science College, Baroda. And without wasting our much time, I request sir to please give us permission to start the session.
Yeah, yes, sir. Go
Yes,
ahead, sir. Go ahead. Yeah. Go ahead, sir. Yeah, you can start the session, sir.
Okay, sir. First, I will call upon. Actually, I request all the participants to be present online. I will call upon the first participant is I will call the number 067 Amar Sanjanrao Tolmare, and the topic is experimental investigation of solar dryers. So I request Sharke sir to please play the video for us. Please, sir.
Sir, please repeat the number.
067.
Okay.
Amar Tolmare.
Sir, please give 1 minute.
Okay, sir. Okay, no issue, sir.
सर त्यांचा व्हिडिओ प्ले नाही होत. आपण नेक्स्ट व्हिडिओ ट्राय
Okay,
करायचा.
okay. Next video try करू sir. Okay. Next, I will call upon Yogita D. Shahakar, and number is 068, and topic is a comparative analysis of in large scale transportation problem to optimize mathematical manipulation. I repeat, 068 Yogita.
Hello everyone. I am Mrs. Yogita Shahakar. Today I am going to present a research paper on comparative analysis of optimization techniques in large-scale transportation problem to optimize the mathematical manipulation. So these are my contents, that is introduction, classical or tabular methods of transportation problem, implementation of tabular methods, computational difficulties, proposed methodology, implementation of proposed methodology, comparison of transportation problem methods, and last is the conclusion. So first is the introduction. So we all are aware about the optimization. So there are various optimization methods are given. So by using that method, we will get the optimum solution. Means optimization is defined as it is the mathematical approach to find the best possible solution out of the available alternatives under the given situation. So in optimization technique, there is one method that is a transportation problem. So for the transportation problem, if we have to find the optimum cost or minimum cost, so there are various methods are given, right? Next, classical or tabular methods of transportation problem. So there are various classical methods are given. To find the initial basic feasible solution, three methods are there: northwest corner method, least cost method, and Huygens approximation. After that, to find the optimum solution for transportation problem, there are two methods: stepping stone method and Moseley method. So all these are the 5 methods to find the optimum solution or to find the minimum transportation cost by using manually. Correct. After that, so here implementation of tabular method. So all these 5 methods are given. By using that method, we can find the optimum solution. So here I have considered one example of power company. So for that example, see, when we are going to solve this transportation problem by using classical method, so there are number of difficulties. Means it required too much computation time to solve the large scale transportation. There is possibility to get the inaccurate solution because of complicated calculation. So it is necessary to apply another advanced method which reduces the computation time and iteration, and also we get the exact optimum solution. So in MATLAB there are various tools are available. So we can apply this optimization tool to the transportation problem. So for that, first we have to convert that problem into linear programming, and after that we can apply that tools. So to avoid that difficulty, we have to use the advanced technique. Now proposed methodology. So just we have seen we have considered one example of power company. So if we formulate that example as a linear programming problem, then problem is like this. Okay. Now next, if we have to solve this transportation problem by using the proposed technique, right? Proposed technique means there are some optimization tools are given in MATLAB. So for that, first we have to identify our problem is linear or non-linear programming problem. So here we have converted our transportation problem into linear programming problem. After that, we have applied the proposed methodology. So this is the syntax for linear programming problem, because our transportation problem may get converted into linear programming problem. So this syntax we have to use to find the optimum solution. Now next, here we have solved this transportation problem first by using the classical method. Then if you see that it takes a more time, more iterations. After that, we have applied the optimization technique, that is advanced optimization tools. By using that tools, we will get the exact optimum solution. And if you compare this classical method and the proposed method, means tools in MATLAB, optimization tools in MATLAB. So if we see cost by using that classical method, it is different, that is 1180, 1080 or 1020. Here we require the minimum transportation cost. And if we find the same by using the proposed methodology, again it is 1020. But if you compare both the method, means classical or proposed methodology, means if you compare the analysis of that, then classical methods takes a more. But if we applied that proposed technique, then only 2 to 3 line coding is there that we have to write, and just we will get the answer, exact accurate answer. Now conclusion. See here a comparative analysis of transportation problem in the large scale transportation, means if there are number of variables are there, more than 3 or 4 variables are there, so it is not possible to solve this problem manually or by using the classical technique. Okay, because there is a more chances to get the exact optimum solution. So for that, optimization toolbox in MATLAB, which is used for a linear programming problem, has been discussed to minimize the total transportation cost. Means the result obtained from that classical method and proposed technology we have compared, then it is clear that this optimization tool in MATLAB or advanced method are more effective than the classical method. So this proposed technique is able to minimize the total transportation cost and find the exact optimum solution. So due to which the proposed technique is the more efficient and convenient and can get the exact optimum solution in less time and iteration. So in this, calculation part is completely avoided. Finally, proposed technique gives the better result than the specified technique in less time and iteration. So this is all about my research paper. So thank you.
Thank you, madam. If there are any question from the participant, so please go ahead. Okay, Nilesh sir.
Yes, sir.
Sir, please go ahead if you have any query.
Sir, it's good presentation. Yeah. Sir, go ahead for the next presentation.
Okay, sir. Okay. Next, Deepak Shahakar sir. Number is 070. Is the application of switch reluctance motor drive in an electric vehicle. So I request Shetke sir to please play.
Hello everyone, this is Deepak Shahakar from Pote Patil College of Engineering and Management, Amravati. I would like to present a paper on application of switch reluctance motor drive in electric vehicle. See, all we know that the climate changes over the last few decades and the shortage of the natural resources, particularly the petrols, diesel and the other resources, it leads to introduce the new concept of the sustainable development, which aims to meet the actual human needs while preserving the environmental, such that the needs of the future generation that can be met. In terms of preventing global warming and conserving natural resources, vehicles are playing a critical role. To reduce the greenhouse gases produced by automotive vehicles, fuel efficiency must be improved while clearing the exhausted gases as well as ensuring the safety. That is very much important. So world are making appeals to the manufacturers and researchers to be aware about the need and development for the electric vehicles. So the challenges is high due to the increasing demand of the for mobility and transport of peoples and goods in urban as well as the rural areas also. So the principal task is to replace the fossil fuel energy dependency particularly and its environmental impact with primary energy resources and that are renewable, which are also secure, sufficient and environmental compatibility. And that's why I select the topic that is nothing but the electric vehicle. But if we understand for the electric vehicle, we are having a lot of options. That means if we compare about the even electric vehicles, there are particularly the electric vehicles are also get classified into the few types. That is the hybrid electric vehicles, plug-in electric vehicles. Okay. So I would like to discuss about particularly the electric vehicle. Okay. Or we can say that the plug-in electric vehicle. If we observe the particularly the plug-in electric vehicles, here I would like to mention what are the resources for the different types of the vehicles. When we are talking about the plug-in electric vehicle, that means it only runs on the electric field. Okay, so it has been get the charge from the charging station and it runs. So in electric vehicles or in electric car, what are the important components? If we see that in that there is an important component is motor, controller, batteries, transmission, braking and steering. And out of this, the most important is nothing but the motor, or we can say that the drive, which actually drives the car or electric vehicle. So let's talk about the which different machine used for the drives. Particularly, we can say that DC machine, it forms a popular application in electric vehicle. Then induction machines, permanent magnet machine and the switch reluctance machine. And that is what I would like to propose. So if we see the advantages and disadvantages of the various motor used for the electric vehicle, particularly as I told, the DC motor found a popular application. So it has, because of its several advantages, that is the speed control, it has the wide range over the speed control. It gives the high starting torque, quick starting and stopping and reversing, acceleration and free from harmonics. Whereas it has the certain disadvantages also, that it has a high initial cost, increased operation and maintenance cost. Okay. Then if we compare the AC motor, induction motor, it also has the certain advantages, but apart from that, the disadvantage is inability to operate at a low speed and produce the eddy currents due to the production of the back EMF. Another option, that is nothing but the permanent magnets machine. Apart from the high efficiency and the smaller and lighter in design, this is the advantage. It has the certain drawbacks also, that is it is very much expensive. So comparing with that, I would like to propose the simple motor, that is nothing but the switch reluctance machine, which has the certain several advantages if we compare with the previous one. That is nothing but it gives the higher efficiency, more power per unit weight, very robust, and we can say that versatile and flexible. And that's why I would like to propose the switch reluctance machine. Though it has the certain disadvantages, that is it is little bit noisy because of its high torque repulsion. But in this paper, I would like to give you the method that how we can minimize the torque repulsion in case of a switch reluctance motor, so that it can found the several applications in electric vehicles. Okay, so this is for today. Thank you.
Thank you, sir. Sir Nilesh, sir, any question to be asked?
Sir, thank you, sir. Really excellent idea is here. So just I wanted to know the innovation done or innovation expected in this particular paper.
Deepak sir, are you
One
there?
question is about the innovation, and second one is about the research gap.
Okay, sir.
So from where sir has started this particular research. Is there participant present?
Deepak sir, are you there?
Okay, if he is not there, then you can proceed, sir.
Okay. Sir, can you do one? Can we do one thing? Those who are present, that participant will be get there only, isn't it?
Yeah.
Okay. Sir.
That will be better idea. Yes.
That will be much better idea. Okay.
Yeah. Yeah.
So I will call upon Prasad Anil Raut. Is there? Prasad sir, are you there? Prasad Anil Raut. 071 is there? Okay. The next one is Bhavna Budhe, Shubham Ranotkar, and Vaishnavi Lothe. Is anyone present from 072? Bhavna Budhe, Shubham Ranotkar, and Vaishnavi Lothe. 072. Is anybody there from this? I repeat, last call. Bhavna Budhe, Shubham Ranotkar, and Vaishnavi Lothe. Is anyone? Okay. The next is Sanjana Vijay Bhavane. Is there? Sanjana madam, are you there? Sanjana Vijay Bhavane, 073. Models and technology used in the smart grid. Okay. I will take next one. Prathamesh Thakre, 074. Prathamesh Thakre, Swarna Bhopde, Vaishnavi Pandit, Rupali Varade, and Prajwal Kade. Is anybody present who represent this paper? Heartbeat and temperature monitoring system for remote patient using Arduino. I repeat, 074. Prathamesh Thakre, Swarna Bhopde, Vaishnavi Pandit, Rupali Varade, and Prajwal Kade. Okay, let's take next one. 075 is Swapnil Tumbawad, is Sanjay Solanki, Vaibhav Hivse, Nikhil Pidurkar, Pooja Kopre, and Ayush Shende. Is anybody there to represent this paper? 075 automatic accident detection, ambulance, rescue, and traffic signal controller. Okay. I repeat, 075, Swapnil Tumbawad, Sanjay Solanki, Vaibhav Hivse, Nikhil Pedurkar, Pooja Kopre, Ayush Shende. Okay, let's take next one. Snehal Rajesh Vadhai. It's 076, power control with active system. Snehal madam, are you there? Okay, 077, Abhishek Gadekar, automatic hand sanitizer dispenser. Abhishek, are you there? Okay, next 078, Ankita Naval Singh Kazdekar, smart grid concept and comparison with traditional grid. 078, Ankita madam, are you there? Okay, next call. I call upon 079 Vaishali Mate, prediction of loan defaulters improvement through comprehensive pre-processing. Vaishali madam, are you there? And the last one, Sanjivani 080 Sanjivani Subhash Rao Gawande, is prediction of loan defaulter improvement through comparison pre-processing. Sanjivani madam, are you there? Nilesh sir, actually problem is that many of these people got some problems regarding their videos. Some that get uploaded on the Google form, some of them uploaded on the mail. So they may got impression that the videos will not get played or not accepted. Suggest what to do now. Shall we play? If you permit, you can play 3 or 4 videos.
Okay. No issue at all. Because instead of playing all.
Actually, first okay, some of them. Okay, not completely. Actually, the first I think I have called upon the Amar Sanjara Tolmare. He is there. Got some problem in playing the video. Amar Sanjara Tolmare is there. Okay. Let us take.
It was almost, I think, from the electrical background.
Yes, electrical background.
So this one, just you can play this 077. If possible, yeah, automatic hand sanitizer dispenser. Let us see the idea.
Idea seems to be very good.
Yeah.
Shetke sir, 077 Abhishek Gadekar, automatic hand sanitizer dispenser. Please play for us.
Hello everyone, in this oral presentation I will explain my review paper on automatic hand sanitizer dispenser. An automatic hand sanitizer dispenser machine is automated non-contact alcohol based hand sanitizer dispenser which is find its use in hospital, workplace and much more. Does not need a water to wash off since it is a volatile and vaporize instantaneously after application to the hand. Ultrasonic sensor sense the hand placed near it. The Arduino Uno is used as a microcontroller which senses the distance and the result the pump running to the pump out the hand sanitizer. The introduction, the demand of the hand sanitizer has surged as the coronavirus broke out the spread around the world. The alcohol gel hand sanitizer are usually applied by squirting the hand sanitizer liquid when one press the pump with the one's hand. It causes many people to come into a contact with the pump handle. Structural design, the motor controller board and the sensor are located at the top of the automatic hand sanitizer device. The device operated by the converting the rotary motion of the DC motor to the linear motion through the crank and the pressing the pump handle of the hand sanitizer the container with the hammer. The motor mounted minimize the shaking and the vibration caused by the operation of the motor. The hammer guide allow to the hammer to move the vertically without destroying in the left to the right direction. The overall size of the automatic hand sanitizer device is 140 mm into 130 mm into 130 330 mm and it is weight less than 1.27 kgs and not including the weight of the hand sanitizer liquid. The manufacturer with the PLA using a 3D printer for a lesser weight. Now we discuss about control design. The automatic hand sanitizer device consists of the power supply, sensor board, motor, controller and the motor. The power supply provided the voltage and the current for the operation of the motor and the board, and its power source is a battery through the regulator, and the board converted 9 volt to a power of the power supply of the 5 volt and applied to the sensor. The IR sensor will sense the presence of heat and motion of the object with the distance up to 50 mm. It sends the data to the Arduino to achieve the pump. An ultrasonic sensor detects the distance of hand up to 35 centimeter. And if the infrared sensor senses the heat and the motion of the object, it will send the data to the Arduino Uno, so that can be activated by a spray pump, and clean reaches to the hand through the small pipe. The sensor connected to the Arduino will start working when the device is activated, and the ultrasonic sensor in the circuit used to detect the distance of the object. The infrared sensor connected with the microcontroller, it will work automatically detect the heat and the object motion. When the input gets the signal, the water will come out automatically through the pump. When the IR sensor detects the object, and the IR sensor light turn on, and the DC motor does about to turn the motion, considering the elasticity of the sanitizer container pump, and the motor rated number of the rotation of 185 rpm. Result: we have designed an automatic hand sanitizer system that is compatible with the various containers. When one moves one's hand close to the device sensor, the hand sanitizer container is pumped once. It is economically and eco-friendly by the decreasing waste of emission. The automatic hand sanitizer device proposed by its paper in ultimately expected to contribute to the contactless hand disinfection in the public places and the various infection prevention. Acknowledgement. This research was supported by the Department of Electrical Engineering, Pote College of Engineering and Technology, Amravati. Reference: Jessica Hill Brown, American Journal and Infection Control, Volume 31, issue in 2nd of April 2031. Satoru Mitsubishi. And the last one is Golan AP, Choi D and Granry A. American Journal of Infection Control 2020.
Okay, thank you. Nilesh sir, I think O74 is also interesting. If you permit us, so we can play it, the last one.
Yeah. Yes, sir. Yes, you can. Yeah, you can.
Shirke sir, is O74 Prathamesh Thackeray on the heartbeat and the temperature monitoring system.
Good evening, sir. Myself, Suvarna Bhopade from PR Pote College of Engineering and Management, Amravati. I am going to present this PPT by the side of my group. Our project topic is heartbeat and temperature monitoring system for remote patients using Arduino. As shown in this slide, these are the various content of this PPT: introduction, objective, problem definition, block diagram, costing, and plan of project. Introduction. In today's world, the maximum use of resources is always complemented. So, the use of wireless technology is enhanced to meet the need of remote control and monitoring. Life expectancy has been increasing worldwide due to significant improvements in healthcare and medical. This wireless technology helps us to monitor patient even when the patient is not in the clinic. It may increase access to health services and facilities while decreasing cost. Heartbeat and temperature monitoring system saves time of both patient and doctor, hence increasing efficiency and reliability of health services. Objective: of this technology is to develop the heartbeat and temperature monitoring system for remote patients using Arduino Uno. The aim of this proposed approach is to design an automatic wireless health monitoring system. Using this monitoring system saves the time of both patient and doctor, increasing efficiency and reliability of health services. Heartbeat and body temperature are the major signs that are routinely measured by physicians after the arrival of patient. Hence, these are the objectives. Problem definition. As we all are aware about this pandemic situation of COVID-19, we can see how much shortage of healthcare equipment in our country. The availability of easy use and less costly medical equipment is very much needed. One of the increasing popular public concern is human health, and anything else becomes meaningless if one gets sick or dead. For this reason, people spend a lot of money to keep sound health. The patient may not interrupt the medical measurement into meaningful diagnosis since they have little medical background. On the other hand, if raw medical data is delivered to doctor, it kills much time and may cause trouble. But in emergencies, time can never be wasted. So, our project is very much useful for medical and healthcare. As per the block diagram, transmitter section and receiver section of Arduino Uno shown. Health monitoring system is done with modules of data sensing, data processing and data communication. These sensors are connected in data sensing modules such as temperature sensor, heart rate sensor. Temperature sensor is used to measure the body temperature. Heartbeat sensor is used to measure the function of heart by blood flow through the finger. The output of each sensor is interfaced with analog to digital circuit ADC pins of microcontroller. Here is the total cost of this project, in which equipments used are Arduino Uno, NRF241 module, temperature sensor, LCD display, heartbeat sensor, potentiometer, power supply. Plan of project. Our plan is to provide easy and efficient way to patients or anyone who need to monitor their health. This project provide quick result with less cost. By means of our model, we help them to check patient heartbeat and temperature. The people who didn't check their health because of some problem, they can able to check health means heartbeat or temperature because of our model. Thank you.
Yes, speaker
Okay,
is
thank
there.
you.
A participant.
Nilesh
Yeah,
sir,
thank you, thank you.
please suggest what to do now.
Yes, sir. Yes. Yeah. Is there a participant present who has presented this particular presentation?
Sir, you are not audible, sir. Hello.
So now am I audible? Hello.
Sir, your volume is very low.
Hello.
Sir,
Just
volume
give
is
me a
very
minute.
low, sir.
Okay, no, it's not following.
Huh, sir?
Hello. Now.
No, sir, still not. No, sir.
Hello. Participant is present there. Hello. Hello.
I no, I guess participant is not present.
Okay. Then no issue. So sir, we can wind up then. So it would be better to wind up really the great presentations. Yeah, Thakre sir. Am I audible now?
Yes, sir.
Okay, so yeah, now the presenters are not there, then we can wind up this session because it would be very much difficult to ask the questions to them. So we can wind up the sessions and really the great presentations presented by the participants. Yeah, hello. Hello, sir. Hello, anyone is there?
Yes,
Hello, sir. I'm
yes,
audible.
Yeah, yes, sir. Now you are audible. I hope, am I also audible?
you are audible, but your voice is low.
Oh, I don't know what happened. Yeah, let me check once. Let me use the speaker. Now it is? Now
Yes,
am
sir.
I
Yes, sir.
audible?
Yeah, audible.
Okay. Yeah. Thank you. So really the presentations done by the presenters are very nice. And again, the concepts which I found from the title of the research is really excellent one. So I congratulate all the participants or all the presenters for their presentation in this particular international conference. And I really thank you all the organizers for inviting me to chair the session. So thank you very much, sir. Thank you from my side. Thank you.
Thank you, sir. Thanks a lot being here with us. Thank you, sir. Thanks a lot. Sir, I think Amos sir, tell me you got another program at 4 o'clock.
Hello, sir. How many presentations
Yeah.
there? Hello.
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 हाँ नीलेश सर कितने
Yes.
presentation है?
Sir, almost done.
now.
Those who were present, we have taken that presentation, and now we can finish.
All right. Then
Yeah, because
Nilesh
the
sir.
presenters are not there, so we can finish it. Yeah.
All right. Then we can finish. And Thakre sir, you can say that validatory will start around 4:15.
Yeah. I will
Okay,
join
no problem, sir,
once
no
my
problem.
program will be inaugurated. Yeah. Here we are inaugurating one more session. So thank you,
Okay.
sir, for invitation. Thank
Okay,
you,
okay.
thank you, my dear friend
Thank
Amol sir and Thakre
Thank
sir
you.
for invitation. Thank you.
Thank
Thank
you, sir.
Yeah.
Okay. Thank you,
Have a
sir.
nice
Thanks
day.
a lot. Thanks a lot. Very wonderful session. I request all the participant to join 4:15 for an inauguration function. Sorry, voluntary function. So be there. Okay. Thank you. Thanks a lot.
What time? 4:50?
Sir, it's 4:15 now. Voluntary function will start at 4:15. Within 10 to 15 minutes. Sir.
हॅलो.
हॅलो सर, नमस्कार.
हा नमस्कार सर.
झालं आता 5
गोंड
मिनिटात
सर.
झालं.
हो हो हो. गोंड सरही दिसत आहेत ना.
हो, गोंडसरे आहे ऑनलाईन.
हो.
हे
हा,
प्रेझेंटेशनचे
नमस्कार.
रिझल्ट वगैरे करून आले.
अच्छा अच्छा, बरोबर, काही हरकत नाही. मगाचं सेशन ऐकलं मी, चांगलं वाटलं सर.
हो हो.
हो.
आणि
जवळपास
पार्टिसिपंट
15-20
बरेच
मिनिटं
होते
ऐकली. हो
ओव्हरऑल
हो
प्रेझेंटेशन करता.
बघितलं
त्यामुळे उशीर
बघितलं
लागला
सगळं
थोडासा.
बघितलं. हो हो.
आणि
चांगलं
सगळेजण
छान.
ऑनलाईन होते मुख्य म्हणजे.
नाही नाही, आता आता ऑनलाईनच करावं लागेल आपल्याला सर, भविष्य आहे आपलं.
हो.
हम्म. बाकी कॉलेजमध्ये परिस्थिती चांगली आहे ना सर? COVID-19 पॉझिटिव्ह काय?
आहेत
कॉलेजचा
आपल्याकडे
पॉझिटिव्हिटी रेट काय?
दोन मॅडम आहेत.
हो का?
हा, त्या
बरं.
चंद्रपूर येणं जाणं करतात.
हो का?
त्या
थोडस
आहेत.
वॅक्सिनेशनवर हे तर करा सर.
हा, द्यायचं आहे आता ते सगळं आता
थोडं
झालं की.
परसिव्ह करा सगळ्यांना,
हो हो
पर्टिक्युलरली टीचर्सला.
हो हो. आता बऱ्याचशा लोकांना मी दिलेलं आहे सर्टिफिकेट देऊनही करून घेतलं.
हो.
म्हणजे 45 जे नव्हते
हो.
त्यांना मग सर्टिफिकेटच्या आधारावर दिलं. मग प्रिन्सिपालचं सर्टिफिकेट घेऊन जायचं होतं ना.
हो हो हो.
ते प्रोव्हाइड करून मग बरेचसे लोक करून घेतले.
नाही, आता काय थोडस वॅक्सिनेशनच आपल्यासाठी एक सॅव्हियर आहे सर.
हा,
बाकी
नाही
आपण
बरोबर आहे.
कशातच नाही, मग आपल्याला काही प्रोटेक्शन नाही बाकी. मग बस
आता
फक्त
महात्मा गांधी
वॅक्सिनच
कॉलेज
लागतं.
मधली एक मॅडम चालली गेली म्हणे.
आता सकाळी ती
हा,
झुऑलॉजीच्याच होत्या ना. हो
उमाटे मॅडम.
हो हो. मला सकाळीच रेवतकर सरांनी सांगितलं आल्याबरोबर.
अच्छा अच्छा.
सावलीच्या आहे ना.
सावलीच्या. हा. आणि त्यांचे
हो
हसबंड
हो.
काही 3-4 दिवसाच्या अगोदर गेले म्हणे.
हो ना हो. फार म्हणजे
हो ना,
काय,
जरा
आणि काय फक्त
झाला.
काहीतरी 2 वर्षाचाच मुलगा आहे म्हणते त्यांना.
मुलगा आहे, छोटासा मुलगा आहे.
फारच म्हणजे फार वाईट वाटतं ना सर. यंग फॅकल्टीज चालली आहे आपली.
हो ना.
तुकुम कॉलेजचे पण ते यंगच होते
हो, ते
सर.
यंग.
32 वर्षाचेच होते बघतो.
हो ना.
हॅलो काटकर सर.
सर नमस्कार, गुड आफ्टरनून.
नमस्कार नमस्कार.
मला काटकर
गुड आफ्टरनून
सरांसारखं टाय
परवार
लावून
सर.
बसायला पाहिजे होतं.
Very good afternoon, Uttarwar sir.
Hello, good afternoon.
एक्चुअली जो सेशन दूसरा सेशन चालू था उसके पार्टिसिपेंट ज्वाइन कर रहे, इसके लिए अपन 2 मिनट राह देखते हैं, बाद में फिर से चालू कर देते हैं.
ठीक है.
ठीक. थैंक यू.
माझा आवाज येतो का सर?
येस सर, आवाज येतो.
येस सर. सर 4:15 सुरू झाले आहेत. ठाकरे सर
चालू करा सर. मॅडम चालू करा.
सुरू करायचं? ओके ओके सर. Respected all delegates, academicians, research scholars, students and participants, a very good afternoon. As we all know, every beginning has an ending, so also this conference. The International Virtual Conference on Materials and Nanotechnology 2021 has come to its final stage. And for the valedictory function, we are honored to have with us Dr. B.M. Bahirwar sir, Principal Guru Nanak College of Science, Ballarpur. We have with us Dr. A.V. Kare sir, Principal PR Pote College of Engineering and Management, and Professor Manish D. Uttawar sir as our guest of honor. I welcome you all for this valedictory function. Welcome you all, sir.
Thank you.
Okay. Now, I would like to introduce today's guest of honor, Professor Manish D. Uttawar sir. He is Director of Innovation, Incubation and Linkages, Gondwana University. He has got 30 years of experience in industry, research, teaching, and administration. He has done graduation in mining, and he has post-graduated in open cast mining from ISM IIT Dhanbad, and has been awarded with doctorate in mining engineering from VNIT Nagpur. Formerly Professor and Head, Department of Mining Engineering, Rajiv Gandhi College of Engineering, Research and Technology, Chandrapur. Formerly Dean, Faculty of Engineering and Technology, and Chairman of Board of Studies in Mining Engineering at Gondwana University, Gadchiroli, Maharashtra. Formerly Dean, Free Cell, Rajiv Gandhi College of Engineering, Research and Technology, Chandrapur, Maharashtra. Till date, Sir has published more than 40 research papers in international and national journals and conferences so far. He is guiding, right now he's guiding academia, industrymen, executives for ME and PhD in mining engineering. As a part of his doctoral study, he has personally participated and presented his doctoral research paper at the 35th International Conference on Explosives and Blasting Techniques, organized by the International Society of Explosive Engineering at USA. He is a peer reviewer for Journal of Quarterly Transactions of SAINM, South Africa. Formerly Dean, Industry Institute Interaction Free Cell of the college, before assuming the responsibility of the engineering and pharmacy faculty at the newly established Gondwana University, Gadchiroli. As a dean, he has played an instrumental role in implementing semester pattern of education with credit grade system across the entire faculty and chaired direction committee to come up with first 76 direction. As a director, he has actively engaged in creation of startup ecosystem, leading to generation of enterprises, establishment of incubation center at the university and affiliated colleges, promoting research across university region by way of formulation of research and patent policy, recognizing research centers, MRPS for faculties, financial support for IPR and copyright, etc. Linkages with regional, state, and national level institutes and organizations for collaboration in training, skill development research, undertaking skilling initiatives for university students, etc. I welcome you, sir, on this occasion of valedictory function. Okay.
Thank you, madam.
And with your permission, I request I would like to invite Dr. A.V. Kare sir, principal of Pote College, to express his or addresses on this occasion. Kare sir, Thakre sir, is Kare sir available with us?
Kare sir, are you available there?
Shall I start or Uttarvar sir will speak out?
Sir, please address us on this occasion. Then we will start with the guest speaker can begin his address.
Okay.
Thank you, sir.
Good evening to one and all present today. On behalf of our college, PR Pote College of Engineering and Management, Amravati, I extend a very warm welcome to galaxy of intellectuals, invited guests, all the participants from various organizations of India and abroad, session chairs, organizing secretaries, and speakers from various countries to the valedictory function of 2 days international virtual conference on materials and nanotechnology. When the conveners from Guru Nanak College of Science consulted conveners from PR Pote College of Engineering and Management, Dr. Amol Nande, Dr. Dinesh Deshmukh, Dr. Nilesh Jadhav, and conveners from PRPCM, Dr. Nilesh Thakre, and Dr. Amol Boyer for hosting a joint venture of international virtual conference on materials and nanotechnology. We permitted conveners from our college immediately, and output is very well organized international conference. Thank you very much, conveners for both the colleges, and hope the same association in years to come. We had invited speakers from Russia, South Korea, China, Israel, and also from India. These speakers consented to be a part of conference and covered different fields of materials and nanotechnology. I express my sincere gratitude towards these stalwarts. Thank you once again.
मॅडम थोडंसं सिक्वेन्स चुकला आपला, पण ठीक आहे, असू द्या, काय हरकत नाही. आता नाही, ठीक आहे. हा, त्यांना बोलवा, त्यांना होऊ दे, त्यांना करू द्या, आणि त्यांचं झाल्यानंतर मग मला 2 मिनिटं कॉल केलं, मला रिझल्ट डिस्प्ले करायचा. मॅडम गोंधळ करून ऐकून घ्या, शांत राहा प्लीज, शांत राहा मॅडम, शांत राहा प्लीज, शांत राहा, बी कूल, बी कूल.
ठाकरे सर, एक्सक्यूज मी, म्यूट सर.
Shall I continue?
Yes, sir. Yes, sir.
Yes, sir.
We are also thankful to advisory committee members, technical committee members, session chairs, organizing secretaries for their support and cooperation. We are also thankful Mr. Praveen Kumar Pote, President PR Pote Patil Education and Welfare Trust, Amravati, Shreyas Kumar Pote, Vice President, our Director Dr. Siddharth Ladke, and Vice Principal Dr. Mohammad Zuhair for their constant support and valuable guidance. We are also thankful to Sardar Nagendra Singh Soni, President Guru Nanak Seva Samiti Ballarpur, and Principal Dr. B.M. Bahirwar, Guru Nanak College of Science, Ballarpur, for their consent to collaborate with our college. Same cooperation is solicited in the years to come. We are also thankful to all teaching and non-teaching staff of both the colleges and all those who have helped us directly or indirectly for accomplishing this conference. Thank you very much.
Thank you, sir. May I now request the guest of honor, today's guest of honor, Professor Dr. Manish Adi Uttawar, sir, to please address us on this occasion.
I will
Thank you,
rejoin.
Patil madam.
Yes, sir.
Are you able to hear me?
Yes, sir. You are audible, sir.
आवाज येतोय ना माझा?
हो येतोय sir.
येतोय.
Very good afternoon to one and all. My appreciation and congratulations to Dr. Bahirwar, who is principal of the Guru Nanak Science College, Ballarpur, for having organized this 2 days virtual international conference on materials and nanotechnology. As far as the Guru Nanak College is concerned, let me, on behalf of the university, reiterate that this is one of the oldest and one of the topmost colleges of this Gondwana University region, and we have a lot more expectations. And my appreciation and congratulations to Dr. Bahirwar for making to the expectations of this university. Really, I am very delighted and fortunate to see that you have organized this conference in a time the whole country, not only the India, the whole globe is facing a huge pandemic, and you have organized this international conference on a topic which is very much relevant and connected to the existing pandemic when it comes to its mitigation. So really, my appreciation, Bahirwar sir, and your team. Now, as Mrs. Patil has introduced me as myself as Director of Innovation and Startup. So, needless to mention, this is a very relevant topic wherein upon I should rather speak. Now, as far as our university is concerned, everybody knows that it is catering to the districts of Chandrapur and Gadchiroli, which is located in the very deep jungles of Adivasis, wherein the Adivasis are inhabiting. And as far as you say, Eastern Maharashtra, which is sharing its border with the Chhattisgarh, Telangana, and MP, where we have the interference of Naxalites. Now, in the pretext of demographic structure of our university, in particular its location, it is the need of this university that our affiliate colleges should come forward, especially the older ones having very good resource in terms of the humans and the physical infrastructure, should come forward and prepare and gear up in a manner to give a shape and recognition to this our newly established Gondwana University. Really, I am very much delighted to see that a nanotechnology and material conference will be organized. And just now I have seen the brochure and what the Dr. Kai, principal of the Pote College from Amravati, has informed these participants and delegates that there were international speakers from South Africa, Russia, China, Korea, and all that. So really, it is very delightful moment for me to be part of this August International Conference. So, ladies and gentlemen, let me brief you as a part of my duties and responsibility, the post which I am right now occupying. It becomes my responsibility to make you aware and propel our affiliate colleges, and in particular my faculties and students, to create a startup ecosystem across the university. Now, as I said, we are newly youngest university of this Maharashtra state, and therefore, as such, we have very lot of potential, in particular when it comes to innovation and incubation. Now, as far as our country is concerned, now let me begin with some of the bulleted highlights wherein you can work upon. Now, way back in 2011, as far as the Global Innovation Index is concerned, India was ranked around 62. Then a bit we didn't contribute towards this, and we dropped to further rank of 81 in 2015. But thereafter, we have started accelerating and creating this ecosystem of startups across the country. And today we are having a position or rank rather at standing at the position of 48 across 131 countries in 2020. So, ladies and gentlemen, what do you mean by startup? Basically, nothing but a young person, maybe one other one, a guy having a new idea, innovative idea, which is having a potential to convert into a useful product or a service or whatever you can say. And thus, it offers a business opportunity, a rather self-employment, and thus in the process, it creates or generates employment for others also. We always talk of the employment potential. You can see there is huge unemployment in our country. So therefore, what is the alternative to this? One can think of generating its own employment, and what is that opportunity? What is we call startup. So, gentlemen, we know some of the policy initiatives the central government has undertaken. You must have heard this name, the Make in India policy, what we call the Atmanirbhar Abhiyan. Then we have got Digital India. So there are such huge initiatives the Union government has launched, and as a part of which we are also trying to contribute. And I see this 2 days international conference a means, or rather a huge effort by one of our topmost and oldest affiliate college of Guru Nanak Science College, Ballarpur, in a way to contribute this creation of the startup ecosystem. Now, as I said, our country is fast emerging as a startup nation and around has created an ecosystem. And today we have been scaled to become the 3rd largest startup hub in the world, followed by US and China. Friends, as on date, roughly we are having around 29,000 startup companies. And by 2030, our union government has targeted an ambitious numbers of 50,000 companies. Now, this is how it is expected that we will achieve excellence in science and technology, entrepreneurship, industrial growth, and thus we will be globally having some economic power. Now, friends, when we started this journey and we have attained this mark, the rank of 48 in 131 countries, wherein Switzerland, Sweden, US, and UK are topping this chart, and we are standing at the 48th position. But still, we are having some, as on date, around 48 startups as unicorn companies. Now, what is a unicorn? Any startup company which is having an annual turnover of more than $1 billion US. So friends, can you imagine this journey of last 6 years or 7 years? In this last 7 years, our government has come forward with policies, schemes, and projects, and most important, financial funding, as a result of which we are having 48 unicorn companies which are having a annual turnover of more than $1 billion US, and our target, another 35 such unicorns are supposed to be released in the coming near future by say 2024, and the ultimate ambitious target is to have 50,000 startups. And for this, the government of India has come up with a Startup India seed fund scheme, wherein they have allocated a corpus of 945 crores, which will be expedited through 300 incubation centers of this country. Our Gondwana University is also process of setting up a incubation center under the aegis of my department of incubation, innovation, and linkages. This Startup India Seed Fund Scheme is supposed to benefit around 3,600 startups, particularly in the Tier 2 and Tier 3 cities. Herein, a company can fetch a maximum grant of rupees 5 crores, and a grant of 20 lakh is supported or extended rather for the proof of concept or any prototype development or any product trials. They are also providing for a financial support of rupees 50 lakhs for startups for making an entry into the markets, for commercialization or scaling the convertible debentures or debt-linked instruments. Most recently, our Honorable Prime Minister of this country has organized an international summit called Prarambh, means the beginning. So what was this event? This event was objected to create a startup ecosystem across the country, which is of the youth, which is by the youth, and which is for the youth. And for these youth, he has made an allocation of rupees 945 crores, which is supposed to be expedited in the next 5 years. So, ladies and gentlemen, this is very remarkable availability when it comes to our country, in particular our union government. Now coming to the theme based on which this August International Conference was organized virtually, the materials and the nanotechnology. So friends, ladies and gentlemen, needless to mention, what does this nanotechnology stands for? Now everyone knows that what is the crisis at this hour. It is not only the nation is facing, but it's a global crisis, what we call the pandemic, and its name is COVID-19. And in that too, when we come to addressing this crisis in particular at this hour, when we are facing a second wave, and there is a huge surge in number of the positive patients and the fatalities. So in this pretext, these materials, the nanotechnology, when taking further ahead the nanomedicines, what I see, the nanomedicine has played a very important role in fighting and mitigating this COVID-19 crisis, pandemic across the nation and the world. Basically, nanomedicine is a very powerful tool, what I see, and it has potential to mitigate the burden of this disease by providing the nanoparticle-based carriers and the vaccines. Ladies and gentlemen, in a span of 6 months, our nation was able to provide 2 vaccines. Can you believe this? Really, it's a very incredible and fantastic task by our scientists, the doctors, and all startup companies, in particular the IITs, the biotechnology centers, the DSTs, and the BIRACs. They have contributed in a very great way. And as a result of which, in a span of 6 months from our first lockdown, our country was able to get 2 vaccines. Not only our country, across the globe, there are multiple vaccines. Now, as an example, on first day, we are getting the first consignment of Sputnik 5, the Russian vaccine. Then thereafter, we are supposed to get Moderna, we are supposed to get Pfizer, Johnson & Johnson from US, AstraZeneca from UK. So there are number of vaccines, and ladies and gentlemen, I'm very delighted to share this fact that the nanomedicine was a major player in the development of these vaccines. So exciting advances have been made using these diverse nanomaterials like the polymerics, the inorganic self-assembling materials, and the peptide-based towards the COVID-19. So when it comes to this global pandemic, we are needing the 3 strategies to address this one, to take care of this. That is the prevention of this COVID-19. Then we have to diagnose this, and then we have to go for the therapeutics, that how we are going to handle and provide the treatment to the ailing patients which are positive and affecting due to this COVID-19 pathogen virus. So in this pretext comes forward the nanotechnology, the very theme based on which this August conference was organized on a spread over the 48 hours of 2-day span. Now in this nanotechnology, we have tools which have been very effective in preclinical studies against a variety of pathogens. Now we have seen, we are facing a second wave, and everybody says that this is double mutant Indian variant B1617, and it is very dangerous. It has found very lethal. The CFR has increased, the positivity rate has increased. So how you are going to assess this? Ladies and gentlemen, it is all our nanoscience and nanotechnology that is enabling our scientists, the pharmacists and the doctors to determine these variations, what is in the form of its mutations. Now, primarily this is a respiratory virus, so obviously it is damaging our respiratory, affecting respiratory system and primarily the lungs. And as a result of which, at this hour, the nanotechnology is drawing a very immediate focus to aid this global COVID-19 pandemic. Bahirwar sir and his team, I hope this during these 2 days long deliberations, there must have been a couple of papers addressing the role of nanotechnology, the nanomedicine, and the materials in handling this COVID-19 pandemic, which is not only present in our nation, but it is global, and that is why it is called the pandemic. So, gentlemen, really we have to come forward Now you can see this COVID-19 during second wave has made inroads in our rural areas. In the first wave, it was confined to the tier 1 cities, the metros and the urban areas. Now in the second wave, it has made inroads in the rural area. Now if you see, compare the rural versus the urban divide, there is a huge socio-economic imbalance. So gentlemen, I see this startup ecosystem a great tool to remove this regional socio and economic imbalance, or rather the divide in between the urban and the rural. Now, for example, Ballarpur is a taluka place, well connected on highways and train, GT route. It is an industrial taluka, but still it is taluka, having limited population. From where you can march, excel, and make inroads into the Gramin, that is rural areas, and benefit the larger, the vast swath of our Indian population. So I hope this is a very platform from wherein we can enable ourselves and provide comfort zones to the rural population by making use of this technology, in particular the nanomedicine and the nanotechnology. So with these words of my information, praise and appreciation on this valediction, let me call it a day. So first of all, I would like to thank our esteemed principal, Dr. Bahirwar, the principal of the Guru Nanak Science College, Ballarpur, and his team, including all the coordinators, the conveners, the core conveners, the coordinators, the advisory boards, the associators, in particular the Dr. A.B. College, principal of the Pote Engineering College of Rauti and his team, and most importantly, the governing trust of the Guru Nanak Science College, Ballarpur, and its president, Shri Soni, and every individual who has contributed directly and indirectly to this August 2 days international conference. Ladies and gentlemen, once again, I extend my sincere appreciation and thankfulness for providing me this opportunity to come up with my piece of note on this valediction ceremony. Thank you so much. I enjoyed this moment with all of you. I wish you all the best. I wish our affiliate Guru Nanak Science College, Ballarpur, under the leadership of Dr. Bahirwar, to achieve excellence and autonomy. Sir, I think you recently have done NAC cycle.
Thank you, sir.
Yes,
Thank you,
so
sir.
I feel your next target should be to achieve the autonomy status.
Okay, sir.
And
we will try our level best.
Whatever support, mentoring you require from university, I am most welcome to extend without any hesitation and reservation from our side. You are most welcome, sir. It is our internal wish from our bottom of my heart and mind that our GN College Ballarpur should achieve that autonomy status. Because you have that potential. Your college has that potential. You have got that team. And today you have demonstrated your potential by organizing this international conference on nanotechnology.
Okay, sir. Thank you, sir.
Thank you so much. Wishing you all the best. Take care of yourself and your beloved ones. Protect yourself from this COVID-19. And with this hope to see you once again. Thank you so much.
Thank you so much, sir, for your valuable words. Now I request the convener of this international conference, Nilesh Thakre, sir, to say a few words on this occasion of valedictory function.
Thank you, madam. Thanks a lot. Actually, I'm here to announce the result of our poster competition and oral presentation. The respected chief guest, Dr. Uttavar sir, sir given a very nice and introductory speech. Thank you, sir. Thanks a lot. Dr. A.V. Kale sir, Principal Pote Engineering College. Dr. Bahirwar sir, Principal Guru Nanak College. All the delegates, the staff members, and the research scholars. A huge response from India and other country also. Almost 300 plus registrations are there, and on social media, YouTube and Facebook. Near about figure, we can't say exactly, but maybe 1,000+ students will be there on participating in the conference from social media. Then for poster presentation, I announced the second best poster is by Priya Dule, is from Guru Nanak College of Pharmacy, Nagpur. I congratulate Ms. Priya. Then,
Thank you, sir.
Okay, thank you. First prize from poster is Mr. Avinash Mende sir, is from V90 Nagpur. Congratulations, sirs. And in oral presentation, the second prize was very nice presentation. Is Baiju V from Kerala University. Congratulations. And the first is very wonderful oral presentation. It's from Remy Dhari, is the Faculty of Science, GAPSA, Toinshia. Congratulations, sir. Hearty congratulations to winners. Thank you. Thanks a lot. And at the end of this conference, I take this opportunity to thanks all the members which have given contribution to each and every sector. It may be the social media, virtual platform, each and everything, adjustments of the sessions, session chairs, dignitaries, all. Thank you. Thanks all. Thank you again. Please, madam.
I now request Dr. Praful Katkar sir to propose the vote of thanks. Sir, you are not audible to us. Katkar sir, तुमचा आवाज येत नाहीये.
Okay, yes. Thank you, madam. Myself, Dr. Praful Katkar from Guru Nanak College of Science, Ballarpur. It is said it is not as important as what we said, but it is very important what we hear and what we feel. That's why we make an effort to create a cluster of people in the form of conference to share valuable ideas. Connecting people around make us a great community of learners. I have an immense pleasure to extend a warm gratitude and heartfelt thanks to each one of you on this occasion of International Conference on Materials and Nanotechnology, jointly organized by Guru Nanak College of Science, Ballarpur, and PR Pote College of Engineering and Management, Amravati. First and foremost, I would like to extend my sincere gratitude to Honorable Sardar Nagendra Singh Soni, President of Guru Nanak Seva Samiti, and Shri Praveen Kumar Pote ji, Chairman of PR Pote College of Engineering and Management, Amravati, for their constant inspiration, pivotal motivation, generosity, and all extendable help. Kind advice with the word of encouragement has only made this possible. I extend a sincere gratitude to the organizers of this conference, Dr. B.M. Bahirwar, Principal of Guru Nanak College of Science, and Dr. A.V. Kade sir, PR Pote College of Engineering and Management, for their all possible help and constructive criticism throughout the duration has enabled the sustained execution of this conference. It is a great honor and I have immense pleasure in conveying my deepest sense of gratitude to Dr. Ashok Joshi, an innovator and technology entrepreneur. This conference has gained more little glitter by gracious presence of Dr. Ashok Joshi. His valuable guidance and the information could be a precursor for the innovation and entrepreneurship development amongst all the participants. I am very much grateful to the Professor H.J. Doble sir for having insight on the luminescence of LED phosphor. All the participants of this conference must have inspired by their highly sparkling words. we are highly obliged by the presence of Dr. Konstantin Ivanovsky. I take this occurrence to convey my sincere thanks for his interactive talk on the luminescence materials. I want to extend my generous thanks to Professor Ramchandra Pote for his informative talk on the OLED operating mechanisms and applications. There is an addition of valuable information on OLED operation to our knowledge. I'm happy to mention my obligation to Dr. Manish Shinde, scientist, CMET Pune, Dr. C. Gainar, material scientist from Israel, Dr. Harna D, NIT Warangal, Dr. R.G. Tangturi from Wuhan, China, Preeti Gupta from Germany for sharing valuable information on their respective research work. I offer my sincere thanks to the chairman of this session, Dr. Gahane sir, Dr. Ishwar Mohule sir, Dr. Sachin Wazalwar, Dr. N.R. Pawar, Dr. Vijay Chaudhary, Dr. S.Y. Mullemwar, Dr. Vijay Pavde, Dr. A.U. Bajpayee sir. I'm very much grateful for their gracious presence on the occasion. I extend my sincere gratitude to the organizing secretary, Dr. Shobha Gaikwad, and Dr. Amol Bhoyer for their all extendable help. Permit me to mention the appreciation and a big thank you to the convener, Dr. A.V. Nande and Dr. Nilesh Thakre sir for their relentless hard work has made this conference possible. It would be ungrateful on my part if I forget to mention the helping hands of Mr. Nilesh Shedke, Avinash Ratte sir, Dr. Dinesh Deshmukh, Dr. Nilesh Zadav, Sapna Sharma, and Sima Bhagat madam for their behind curtain work that has made this sustained execution of this conference. I also convey my sincere gratitude to the Dr. Manish Uttarwar sir for gracing the presence for the today's validator function. Before concluding, I would say, amid this pandemic, your life is precious, so stay at home, be kind and support to one another. Our unity will destroy this small yet big enemy if we follow all the safety measures. That's all from my side. Thank you very much for everyone. It's been wonderful to have you all participant during these 2 days. Thank you so much.
Thank you, sir.
Thank you, sir. Thanks a lot. With the permission of chair, we can declare the if nobody want to share his views, the program is over. Chairman sir, chief guest sir.
Yes, sir.
With the permission of chair, I declare the program is over.
Program is over.
Thanks
Yes.
again. Thank you, sir. Thanks a lot. Thank you, sir.
Thank you, Thakre sir.
Thank you.
भेटू म्हटलं एखाद्या वेळेस पर्सनली भेटू
सर नक्की हो सर नक्की येतो सर आम्ही आलो की सर भेट घेतो सर आपली
या सर थँक्यू
थँक्यू भैरवर सर थँक्यू सर थँक्यू
थँक्यू
भेटू
मॅडम
नंतर कधी
ओके सर
थँक्यू सर
चला चांगला ग्रुप फॉर्म झाला आपला कंटिन्यू करूया
आणि
फ्युचर मध्ये
हो सर तुमच्याकडनं सर अशीच अपेक्षा आहे सर
बिलकुल सर
थँक्यू सर
ओके सर थँक्यू
उत्तरवार सर गेलेत का सर उत्तरवार सर
बहुतेक झाले डिस्कनेक्ट झाले वाटतं
ओके सर चालेल ठीक ओके सर थँक्यू सर थँक्स अ लॉट